In this video, we are going to set up a development environment for the component library and also for the Next.js apps or the documentation websites we will be building later in the series. So the first thing we will need to do is create a folder anywhere on your computer, and you can name it whatever you want based on the name of the organization. In my case, I have named it mod.js because I found that name to be, or this organization name or the project name to be relevant to what we are doing. Mod means module, so module.js, mod.js, I think that makes a lot of sense in my understanding. But you can name it whatever you want. So create a folder anywhere on a computer, open up VSCode. And in VSCode, click on File and click on Add Folder to Workspace and add that folder to VSCode. And as soon as you do that, click on File again, and you will hit that Save Workspace As, and then save this workspace somewhere in desktop and name it whatever you want, okay, the name of the workspace. And once you have that, close the VS Code and open up that workspace file, and then you will come to the exact screen that I am in right now, okay. And this workspace thing in VS Code is important because later on when we use Prettier in order to format our code, and also for Eslint, I found that VS Code does not have a lot of synergies with those two technologies. So just to be on the same side, or just to be on the safe side, or just to be consistent with your environment and my environment, let's do that so that we are exactly using the same environment, okay. So once you have that, once you have the root folder, the project folder on VS Code, as you can see, I have that too, and inside that, this mod.js folder is completely empty. So this is the main root folder. This is also the mono repo. So if you have watched my last video about the entire architecture of the series, I explained this big diagram here in part 2 of this series. So if you have not watched that, go and watch that video. You will understand everything that's going on in this diagram. And in that video, I also talked about some concepts of monorepo architecture, microservices architecture. So I think it's really helpful if you know everything that's going on in this diagram, because this is the diagram we will be following throughout the series, so that we have a reference to our project structure and everything else, okay. So as you can see, this was the mod.js root folder. We just created that root folder and imported it in VS Code like we did here, okay. So that's the root folders. The next thing we will do is go to nodejs.org, okay, because we will need Node.js for at least just for the tooling. You really do not need Node.js if you are writing just a React application, but in this series we will be doing more than just React. We have to deal with TypeScript. We have to set up a development environment. We want to make sure that everything works out well, and also our end product is 100% optimized. So we need Node.js for all the other things that we're going to talk about soon here. But go ahead and download this long-term support version of Node.js, okay. So LTS means long-term support. It's always better to download the long-term support version, and it looks like the current long-term support version is 20.15.1. So go ahead and download Node.js, and when you do that, it will also automatically install npm for you, which is a Node package manager that will be used to install and uninstall the package and manage our entire workspace as well, okay. And so if you do not know what Node.js is, let me give you a quick introduction to Node.js, and also for my own review, because every single time I talk about Node.js, I want to dig in a little bit deeper, because Node.js is such a popular runtime environment. It is really powerful. It is really fast, so it's always better to know at least a few things about Node.js. As you can see clearly on the screen here, Node.js is marketed as run JavaScript everywhere. Node.js is a free, open source, cross-platform JavaScript runtime environment that lets developers create servers, web apps, command line tools, and scripts. And before I explain this any further, if you know all these concepts, I'm going to put a timestamp in the description section below, so that if you already know these concepts, and if you do not want to sit there and listen to me blab about concepts you already know, feel free to increase the playback speed or jump to the section that you want to watch. Okay, you're free to do that, but for any beginners out there, I want to be as detailed as possible, so that new people watching these videos, they understand the core principles behind the technologies we use, and they also know how some of the tools work and how the technologies work. Instead of just using it, it's always beneficial, especially when it comes to troubleshooting. It's always beneficial to know how technologies work, okay? Because we are programmers, we are developers, we are the one that build this technology, okay? And as a developer, it's important that we understand how technology works. The end user, something that does not have interest in programming or coding or developing things, somebody that is just a user, they do not need to know how things work. They just want things to work, and that's it. They do not care about how it works, how it's made, but we as a developer, we need to know it. So JavaScript is a runtime environment. So in order to understand this, I hear a lot of people confused about Node.js, Next.js, and even some of the other technologies that sound similar, but it's completely different. Next.js is a totally different thing than Node.js. Yeah, both of them are built on top of JavaScript, but there's a huge difference. Next.js is a library, or even more than a library. It's a framework for web development, and it's mainly built on top of React, that itself is built on top of JavaScript. Okay, so when we are talking about Next.js, that's a web development framework, but Node.js is a JavaScript runtime environment. It is not a library, it is not a framework, it is not anything like that. When we say what Node.js is, we say that it's a JavaScript runtime environment. And in order to understand this, we have to dive into history a little bit. So before, in somewhere in 1995, or even before somewhere around 2005, JavaScript, the main purpose of JavaScript was to make websites more interactive, and JavaScript could only be run in a browser, like in Google Chrome here. Okay, and before Node.js came in, yeah, I think Netscape had some technology that would run JavaScript on the server side, but Node.js is the one that brought server-side JavaScript to spotlight. So the author of Node.js, the guy that wrote Node.js, his name is Ryan Dahl. So what he did was, to build Node.js, what he did was he extracted something called Google's V8 engine. So Google Chrome has Google developed V8 engine, and that engine is the engine that runs JavaScript in the Chromium browser. So in order to run JavaScript in Google Chrome here, that's the browser I have open, so I can go to console, and if I just type in console.log, if I type in hello, you see that the hello will be printed. We can run JavaScript right in the browser, right in the console here. And this is possible because of Google's V8 engine in all these Chromium browsers, like Brave, Opera, Google Chrome. These are all Chromium browsers. So we can directly run JavaScript in the browser, okay? And it will print hello there. So JavaScript always ran in browser. There was not a big problem. But what happens if you come to the terminal here in VSCode and write on a mod.js, you type in a node, like if you already have this installed. But what would happen is, if you did not have node installed, okay, and you type in node, this shell would not appear. And if you just type in, like in the shell, now I can type it in, but if you type in console.log in terminal and hit enter, it is going to give you an error, because JavaScript only runs on the browser, or on the browser without Node.js. Okay, but with Node.js, if you already have Node.js installed, type in node, and in that shell, if you type in console log, type in hello, you see that hello is printed, and we are running this JavaScript this command, console log command, outside of the browser in this VS Code terminal, and we can see that it still prints hello. Okay, so we know that with Node.js, JavaScript was already running on the browser. Now it can also, Node.js with JavaScript, we can run JavaScript also on outside of the browser with the help of Node.js. Okay, so Ryan Dahl, the writer of Node.js, what he did was he extracted that V8 engine, that Google's V8 engine, and that is the engine that runs JavaScript, just like your car runs all four wheels of your, your car engine runs all four wheels in your car. In the same way, JavaScript engine runs JavaScript code in the browser. Okay, so what Ryan Dahl did was he extracted that V8 engine from Google, and that V8 engine is open source, so anybody could extract that. So Ryan Dahl extracted that that V8 engine from Google Chrome, and he embedded that engine, that V8 engine, the JavaScript running engine, into C++. And if you know C++ a little bit, or if you even have heard about it, C++ is a low-level programming language that can directly interact with the computer system, with the machine. Okay, we can read file, we can write file, we can do a lot of things. We can directly interact with the machine at the lowest level, and C++ is a low-level language, so every interacting with the system, with the machine, is possible with C++. So when Ryan Dahl embedded Node.js, or the V8 engine, into C++, so he did that. He embedded V8 engine into C++, and then he called it Node.js. Okay, and with Node.js, the JavaScript was already running on the browser. And with Node.js, we can also run JavaScript outside of the browser. And this is possible because Ryan Dahl, the writer of Node.js, he took that V8 engine and then embedded it into C++. And now Node.js can interact with the computer system. Node.js can run on the browser, JavaScript can run on the browser, and we can write JavaScript code outside of the browser also. Okay, so that's the core concept behind Node.js, and that's why we don't call Node.js a library or a framework, but it is more of a JavaScript runtime environment. Okay, because it helps us run JavaScript within the browser and outside of the browser too. Okay, so that's the core concept behind Node.js. And before jumping into anything else, there is let's try to understand the architecture behind Node.js 2, because this is going to be super helpful when we actually begin writing code for our component library, and also for the documentation websites we will be building. Okay, and if you already know these concepts, again, feel free to increase the playback speed or jump to the section looking at the timestamps below. Okay, if you are bored hearing this, but I think it's really important, and this is going to be super short. It's really important to understand Node.js. So let's consider this box here. Let's call it a Node.js server. So this box is a Node.js server. Okay, and since Node.js can be used outside of the browser, we can also make a web server with Node.js. Okay, so think of this as a Node.js server, and this server, inside it, there are a few things. There's this another box called event queue. Okay, and this concept is really important. That's why I'm explaining this. This is not a Node.js course, but I think it's really important to understand some of these core concepts. Okay, so inside this Node.js, there is this box here. This is called an event queue, this box. And there is this, let's consider there's this another box here, or a system. Okay, but to understand it better, let's just call it a box, because that's what you are seeing on the screen right now. So there's this another box here called event loop. And this box is called event queue. Okay, event queue. So this is the Node.js server with event queues and event loop. Okay, so what happens is, whenever a client, let me pull out a user. So whenever this is the, whenever this client, this can be you, me, but in reality, this is the web browser, right? This is Google Chrome, Mozilla, whatever web browser we are using. This is the client or a user, you, me, anybody else, okay, that is going to interact with this Node.js server. So this user will send a request to the Node.js server, okay, and then what happens is this request that is being sent, I will mark that as, I'll put a small box there. So this is the request. So this request, whenever the user sends this request to the Node.js server, this request gets lined up in this event queue, okay. And let's say that there is another user that is also sending the request. So all these requests gets lined up in this event queue, okay. So, and there might be some more users that is interacting with this Node.js server. The user send the request, and all these requests gets lined up, gets queued up, okay, in this event queue. And then what happens is this event loop here will pull each of the requests that is in the event queue, because Node.js cannot directly perform operation on every single request that it receives. It depends on the computing power, okay, but in most cases, this event loop, all the requests from the user will be put into this event queue, and the request in this queue will be processed one at a time, okay. So this event loop will take this request from the event queue. So event loop now has the request, and then what event loop will do is event loop will try to figure out, and this is the most important concept that, as I've been stating, that we will be using throughout the series, and this is also an important concept in JavaScript, anything that has to do with JavaScript, but mainly in case of Node.js. This is really important. So this event loop will try to find out if this request is this request a synchronous request or a blocking request, or is this request an asynchronous request or a non-blocking request. So the synchronous means also called a blocking request. This asynchronous request is also called a non-blocking request, okay. So event loop will try to find out if this is a blocking or non-blocking request. If it is a non-blocking request, in other words, if it is an asynchronous request, then this event loop will immediately process this request, this asynchronous request, and then send the response back to the user, and then the user gets the response, okay. And the other scenario is this request can also be a synchronous request. So event loop finds out that this request is a synchronous request. So in this case, things are going to be different. So what's going to happen is, as soon as event loop finds out that it is a synchronous request, event loop is going to send this synchronous request to something called a thread pool, okay. So event loop sends this request, this synchronous request, to a thread pool, okay. And this thread pool, you can think of thread pool as a collection of threads. Also, you can also think of threads as being a worker, and worker is something that does your job, a system that does something, or in this case, thread is a worker or a system that processes this request, okay. So in case of synchronous request or a blocking request, event loop sends this request to thread pool, and each of the threads within this thread pool, or each of the worker, processes this request, and it will be sent back to the user as a response, okay. So there is another important concept when we talk about this. So this thread pool, the number of workers within this thread pool, it depends on how powerful the computer system is, the machine is. So by default, this thread pool has 4 workers or 4 threads, okay. So what can happen is, let's say that there are 4 users making a request, and they are all making an asynchronous, or they are all making a synchronous request right now. These are all blocking requests, okay. So that's a blocking request. This is also a blocking request. This is also a blocking request or a synchronous request. Okay, so there are 4 users making a synchronous request to Node.js server. The synchronous request is stored in event queue. Event loop gets each one of those requests. So there are, let's make it 4 requests there. And because since all of these requests are blocking requests, synchronous requests, event loop sends it to the thread pool. And in thread pool, we have 4 workers or 4 threads. All these 4 threads can easily process these 4 requests. Because there are 4 requests, there are 4 workers. So all these 4 workers can process all these blocking requests all at once, and the user gets the response pretty fast. But the question here is, what happens if there is another user making a blocking request yet again to the Node.js server? So before we had 5 users and 5 workers. Now we have 5 users making a blocking request to the Node.js server. The blocking request gets lined up, that gets queued up in the event queue. Event loop gets those blocking or synchronous request, and then if the request is synchronous, then event loop will send this new request to the thread pool. Now this blocking request, the new request, is on the thread pool also, okay, somewhere in the thread pool. But now what will happen is that there are 4 workers, but then there are 5 different requests. So do we have a new worker for this blocking request to be processed, for this new blocking request to be processed? We do not. Okay, so this blocking request, we do not have any other workers. So what event loop is going to do is event loop will keep this blocking request on its own for now, okay, until one of these workers is free of their work. One of these worker is not busy. And as soon as, let's say that this worker is not busy, okay, he's not doing anything. So once one of these worker is not busy, event loop will send this blocking request to this worker, and now this 5th user's blocking request can also be processed, and the request can be sent, response can be sent back to the user. That was the concept about thread pool. And can you increase the size of this thread pool? Instead of having 5 workers, let's say that maybe you want to have thousands of workers or these threads in the thread pool. Is that possible? Yes, that is possible, but it depends on how powerful the computer system is, or how powerful the machine is, how many vCPUs you have. That's what it depends on. So let's say that if you have 8 vCPUs, maybe you can have 8 threads in this thread pool, so that all those 8 threads can process all these 8 requests all at a time. But if it's not a powerful computer system, if you do not have a lot of vCPU, then by default it's this thread pool will have 4 threads. In order to increase this, you need more powerful machine. Okay, so that's the entire architecture of how Node.js works, and this is really important because we will be writing a lot of synchronous code, asynchronous code, and even in concept of even in JavaScript, this is a similar concept because Node.js is built on top of JavaScript. Okay, so this was one important thing I wanted to explain, and that was I went in quite a greater detail in that, but this video was not supposed to be a Node.js architecture video, but just so you understand, I think it was a little helpful for you. Okay, so without any further delay now, install Node.js. I believe you already have. So once you have installed Node.js, go to let's come back to VS Code and let's type in node-v, and this will give us a Node version. I am running Node version 20.10.0, and this is different from your version, which is 20.15.1, but I think it is going to work. To be on the safe side, you can go and install Node.js version 20.10.0, but I really do not think this Node.js versioning will make that much of a difference, because the major version is still the same, that is 20, just the minor version has changed from my Node.js version is 20.10, that's the minor version, but the latest minor version is the minor version is 1.5. Okay, I think everything should be fine, even if you have the latest version. I do not have the latest one, and I do not feel like I want to update it right now, especially when I'm making this series. Okay, so once you have Node installed on your machine, as I stated earlier, you can just type in Node and a Node shell will pop up. You can run console log or any JavaScript statements you want there. Okay, so once you have Node installed and verify that you have a Node.js version running, also let's check if npm is installed. So npm-v, type in the command. You can see that I have npm version 10.3.0 installed. Okay, so we have Node and we have npm. So now it's time to finally come back to this root folder, mod.js. And again, I'm going to refer back to this architectural diagram when I'm talking about this project structure. So this is the root folder mod.js that I already have, that you already have. The next thing we'll do is we will begin installing these packages, and I will talk in greater detail about each of these library or each of these dependencies that we will be using throughout the series. Okay, so once you have this mod.js folder, open up a terminal. Okay, I believe you already have it open, but the first thing we'll do is in the root folder, in this mod.js folder, currently it's completely empty. Okay, we will type in npm init, and I'll also put a -y flag in there. You do not have to put it if you do not want, but that -y flag basically means yes to everything. So this is good. Just going to create this. Once I hit enter, it's just going to create this package.json file. Okay, so in this package.json file, let's come up here. It automatically created the package.json file, and it did not ask me any questions because I put in -y flag in there. If it did not put -y flag in there, then it would ask you some question like what your name of the package is, description and all that. But anyways, that's super simple. But come to this package.json file, and now let's start editing some of this here. So this package.json file is the monorepo. Okay, this main folder, mod.js folder, is the monorepo that I explained in the last video. This mod.js is a monorepo, and the package name is mod.js/monorepo. Version is 1.0.0. So let's go ahead and do that. So I will name it. And in scope package, always make sure the scoped package starts with @ in the beginning. So mod.js. I'm having a hard time typing because my microphone is not aligned exactly with the keyboard, and I'm not sitting straight here. But so let's name this mod.js/ I will name it monorepo. Okay, and that's the scoped package, and in your case this name is going to be different, so name it whatever you want. Do not name it mod.js because you'll have a problem if you name this package mod.js, and when it comes to deploying this package to npm, you cannot deploy under mod.js. Okay, if you plan on deploying the component library, so name it something different. Okay, instead of mod.js, name it whatever JS you want, name it that, and make sure that right after the name you put a slash and specify it as a monorepo. Type in monorepo there. Version, we will keep 1.0.0 for now, and we will talk about semantic versioning as we go on in the series. This is not the important concept we'll be talking about later. Everything else, description, I'm going to leave it blank for now. Okay, the other important thing we'll be doing, let's actually just get rid of that main property. Description property also, let's leave it blank. Let's specify a property called private. And let's set it to true. Okay, so what this is going to do is whenever we set private true in package.json, and you can always refer to the documentation in npm. It's always better to read the documentation in detail instead of having to listen somebody explain this. I think you'll understand it a lot better once you read it on your own. But just to give you an overall idea, when we set private true in package.json, it means that this is a private repository. This mod.js/monorepo, this particular package is a private package. It should never be published to npm because this root folder mod.js is a monorepo. It is not the actual package that we'll be developing. This is a monorepo that contains all our packages and that contains the documentation website and everything. But this mod.js package itself, because mod.js is a package too, right? Because we initialized this mod.js folder to be an npm package. It is a package, but we are not publishing this mod.js package or the mod.js/monorepo to npm. That's why we set private to true, in order to stop accidentally publishing the package. Because if we do not set this, and if we try to publish this package, it is going to publish a package called monorepo under the mod.js scope, under the mod.js organization in npm. Okay, so let's set private to true. And then in scripts, we will come back to script section later. Let's leave everything else as is. Okay, we can always modify this when we are deploying the package. The next thing we will do is we will need development dependencies that we need to install. Okay, so, and all these dependencies here, and again I'm referring back to this diagram, you can see that these are all the dependencies that we need. We need Babel, TypeScript, Webpack. So let's go ahead and install each of this. And to do this, I'm going to write all the packages that we will be needing. So I'm going to write it like that, and I'm also going to specify a version. So I want to use version 7.24.5. okay, and these are, most of these are latest versions. You do not need to worry about your packages or the dependencies being too old. Most of these are already latest versions. Okay, so let's go ahead and install Babel CLI. Let's also install Babel core, and let's also install Babel. This is a preset env, and I'm going to explain what each of these packages does, okay, when I explain Babel. So Babel preset env, and because we are dealing with React, we'll also need Babel preset. I'm really having a hard time. I'm usually a super fast typer, but let's also do preset TypeScript. Okay, Babel preset TypeScript. So we have CLI core, preset env, preset React, Babel preset TypeScript. So these are all the Babel packages we need. If you do not know what Babel is, this is the Babel's official website. Babel is a JavaScript compiler. Okay, so that means that JavaScript has different versions, and a major release was made in 2015 when ES 2015, or also called ES6, was released somewhere in 2015. And before ES6 was released, we could not write JavaScript arrow functions. And if you're watching this series, I do assume that you have some JavaScript knowledge, but even if you don't, I will try to be as detailed as possible. But before ES6 or before 2015, JavaScript did not have some of the new features that JavaScript currently has. It did not have mainly arrow function. It did not have some other features. But with the but after ES6 or after 2015, there are tons of new features that is available with JavaScript. And what can happen is a client or a browser running our code might not have new version of JavaScript available, or they might not have or maybe JavaScript version 2024. So what Babel is going to do is Babel is going to take our JavaScript code that we write with new features. We're going to write arrow functions. We're going to write new features that is provided by JavaScript. So Babel is going to take our new JavaScript and it is going to transpile. So Babel is a transpiler, okay, that translates one source code into another. Okay, so Babel will take our new JavaScript that we write, and then it will transpile our new JavaScript code into a older version of JavaScript, so that our JavaScript that we write with new features like arrow functions and all that, Babel will automatically translate the source code so that the JavaScript we write can be used on the older browsers also. Okay, so that's everything that Babel does. It's super simple. Okay, and inside each of these packages, these are several Babel packages. So Babel CLI that will and Babel core. So this is the core package, and we need Babel preset env. So this preset env, there is not a package. This preset is just a collection of packages or plugins. Okay, so Babel, whenever you see Babel preset something, or even in the world of dependencies, whenever you see a preset, it usually means that preset is a collection of plugins or other packages. Okay, so they take all these plugins or packages and then they jam it together and then they call it a preset, so that the user that is using these packages, you, me, do not have to install every single Babel packages individually. Okay, we'll just do Babel preset env, and that'll install a ton of packages that that we need with a single command. Okay, Babel preset env. And if you want to know deeper about these presets, and we also have Babel preset React, Babel preset TypeScript, because this is a TypeScript project, we will need the Babel's preset for TypeScript also. Okay, and if you want to know more about this, what each of the preset does, so if you come to Babel preset env, let's jump back to ES 2015 for now. So you see they have arrow functions. So this plugin here, this preset env, so this, because as I stated earlier, preset is a collection of plugins. So this preset env contains a plugin to deal with arrow functions. Okay, so this preset env has Babel plugin transform arrow functions. So this is the plugin it has under Babel preset env. They also have block scoping. So all these functionalities, this can be maybe a different package too, right? So let's say that arrow function, we can actually install this package from Babel. We can install only the plugin or the transform arrow function plugin from Babel. But when we install Babel preset env, it is going to install all of these individual packages. It will be under preset env. So when we install preset env, we do not have to worry about installing each of these plugins, these arrow functions, block scoping, classes, each of these plugins. We do not have to worry about installing these individually. Okay, so that's about preset env. Same thing with preset React, same thing applies. Same thing with Babel preset TypeScript, same thing applies. So now let's move on to dealing with some of the other packages here. So we have Babel. We will need Webpack, and for Webpack we are going to install Webpack version 5.91.0. Just to be on the safe side, I recommend you install these particular versions so that your code, because our code will most likely be the same, so that our environment is the same, so that you do not have any errors when running things. Okay, so we need Webpack. Let's also install Webpack CLI, and for this we'll put a caret, and we will install 5.1.4. and I do not remember all of these on top of my head. I'm looking at a note here. Okay, I'm not do not have that good of a memory power to remember every single thing. But next thing we'll install is Webpack dev server, and this will be version number 5.0.4. Okay, so this is for Webpack. We have Webpack CLI, Webpack dev server. For Webpack, so if you are watching this video and if you have come this far, we will not be bundling our component library. We will leave that to the client or to the user, whoever is using our component library. They are responsible for bundling it, because if we bundle the component library using something like Webpack, then the bundle size can be huge, and the client will have no way to, the user that is using the component library, they will have a very hard time optimizing our production code. Okay, so we will leave the bundling to the user using the library. But the reason we need Webpack in this is because when we develop the component library, each of the components that we develop are standalone components. Okay, so you will see later we will use Cypress for this. Cypress is a testing framework, but again, we can also use Cypress in order to visually see the UI or the component that we are developing. So we will need Webpack in order to run the development server that Cypress needs. So that's all Webpack is for. And if you want to learn more about Webpack, go to webpackjs.org, and they have this super nice diagram that shows everything that Webpack does. It bundles your assets, it takes your JavaScript, images, CSS, and it bundles them and optimizes them and produces an artifact. Okay, so that's all Webpack does. But in our case, we will use Webpack in order to run the Cypress dev server, or in order to run Cypress. Okay, so that's for Webpack dev server. And the next thing we will need, I forgot to include one library here. There is also another library we need that's called Babel plugin styled components, and this is mainly for styled components, so that Babel can work nicely with styled components. So let's go ahead and install this Babel plugin styled components also, and this is version 2.1.4. okay. So the next package we will be using is, as I stated, it's Cypress. So this is the testing framework. You will see it later. I have Cypress version 13.9.0. This is really important, especially for component library, because to develop component library, we will be developing within Cypress. Okay, and Cypress is a automated testing framework. You go to cypress.com, test, automate, accelerate. Okay, and as you can see, they have a nice video here that is automatically running everything that's in this particular web page. Okay, this is what Cypress looks like, and this is all the test that the Cypress is running, and this is the UI. Okay, so this is what we'll be doing. We'll be developing the component library under Cypress. Okay, and the real documentation websites with the Next.js apps, that one we will be developing in localhost in the browser. Okay, but for the components, we will be developing within Cypress. Okay, so for Cypress, we need Cypress version 13.9.0. Let's also install code coverage, because as I stated in my last two videos, that we will be doing 100% test-driven development. So we are going to need a Cypress code coverage, and we will set this up later in the series. Okay, so that's Cypress. For Cypress package, I think those are the two ones. So after Cypress, let's go ahead and install another package called Eslint. Okay, so this is Eslint, and for Eslint, we also need Eslint, the main package. We need Eslint for JavaScript, Eslint.js. Make sure the version number is correct, so that you do not come to any problem when you are working in the series. Let's make your and my environment the same, and then you can always update things later when you are confident about this environment that we are developing. Okay, so that's TypeScript or the Eslint for JavaScript. So we also need Eslint for TypeScript, because Eslint, all it does is, Eslint is used for linting our JavaScript code or TypeScript code. And by linting, what that means is, let's say that the code base is going to be super huge. We'll have a lot of files. And let's say that, because we usually do not want console log statement in production, right? Because if we have console log statement, like if Node.js had console log statement in their production website, then we will see the console log logging things in the console here, and that is a security issue. Okay, we do not want console log. We do not want to console log anything out in production in a production app. So with Eslint, what we can do is we can tell Eslint, hey Eslint, find any console log statements that are in my code base, in this huge code base, and warn me about it. Or we can also tell Eslint to throw an error if there's any console log statements. And we can do many things with Eslint, not console logging. It will make our life a lot easier, as you'll see later. Okay. And similar to Eslint, we will also be it's not a linting tool, but we will be using Prettier. We do not need to install Prettier here, but well, we do need to install Prettier here. So let's go ahead and install Prettier too, just along with Eslint. So that's Prettier. Okay, and this will be basically used for Prettier will be used for formatting our code, so that let's say that as we write the code in real code, let's say that I have all these white spaces, or maybe I have tons of white spaces here. it's not easy to read. So what Prettier will do is Prettier will automatically format this and remove all the white spaces, and maybe if it needs an indentation, maybe it will if it needs an indentation, it will put an indentation automatically. So that's why Prettier we need Prettier in development environment, especially when you are working on a team. You want the entire code base, all the developers' code, to be consistent, and Eslint and Prettier allows that. Okay, it makes it easier. So that's for formatting and linting. And let's install TypeScript. Okay, let's put in TypeScript there, and these are not being installed correctly. I'm just specifying the versions and all the tools and technologies we'll be using. And again, if you already know these concepts, feel free to increase the playback speed, jump directly to the timestamps. Okay, so let's do TypeScript. I'll try to go a little fast here. So after TypeScript, we will also use CS loader. So this will be with Webpack. We will need CS loader in order to load CSS. We will also need style loader, and this will also be used by Webpack. We will also use TS loader. This is the TypeScript package. Okay, so TS loader, and then for TypeScript, we will also need all the types for React. So this @types/React package provides all the types for React. Similar to React, we will also need types for React DOM. Let's go ahead and install that. Make sure you have the same version, so that again so that you do not run into problems in the future. So after that, let's go ahead and install some libraries for our unit testing or integration test. So I have testing libraries /React. So this is mainly used for integration test, but can also be used for unit test. Okay, so testing library React, and for testing we also need JS DOM. Okay, so that's JS DOM 24.1.0. This provides a DOM environment in order to write our test. That's all this package does, because when we run our test, we are not running the test in the browser. We are running this. We will be running the test in a headless environment. That is a browser without the GUI. We will be running in the browsers headlessly. Okay, we will be running it in the terminal. So that's why we need JS DOM, so that the terminal has access to the DOM environment that only browser has. So JS DOM provides that browser environment outside of the browser also. Okay, and let's also install Vitest. Okay, this is another unit testing framework. We will be writing unit test, integration test, component test with Cypress, end-to-end test with Cypress. But for unit and integration testing, we'll be using testing library React, JS DOM, and Vitest. Okay, so and let's also install Vitest UI. This will give us a nice UI, just like Cypress. That will tell how many codes are running, how many tests are running, what the test suite or the test cases look like. Okay, so let's install Vitest/UI. And just like with Cypress code coverage, we also need code coverage for our unit test and integration test. So let's install Vitest /coverage-v8. Make sure the version is the same. Okay, and let's also install this package called types/uuid. This package, we will not need this package in component library. We will need this package when we are making a documentation website, and then in that we will have contact form. And like as I said, we will also be dealing with deploying the production site or the documentation site to AWS. And over there, we will have a contact form where people can contact us, or maybe if you want something else or some other forms, you can do that. But when we do that, we will use AWS, and then we will store that contact message up in DynamoDB. And in order to store something in the DynamoDB database, we will need to generate a unique ID. So let's go ahead and do that right now too. Okay, so that things are easier in the end. So that's type/UUID, and the last and final package that we will be installing is a utility package called npm run all. So this will essentially allow us to run multiple scripts all at once using npm run link. Okay, so those are all the development dependencies that we need for this entire project, and these are all development dependencies. Do not install it, do not specify dependency, rather specify dev dependencies, because we do not need any of these packages in production, because in the end the end product that we will build will be a plain HTML, CSS, and JavaScript file. Okay, no matter how advanced, how high level technologies like React, Next.js, everything that we use, in the end it is going to be compiled to plain HTML, CSS, and JavaScript. Okay, and we are doing this just for the development purpose, just so that our development environment is robust. We have code consistency. We find errors earlier in the program. That's why we need all these packages as a dev dependency. We do not need this in production. Okay, so that's all for that. For the dev dependencies for this monorepo. So the next thing we will do is let's save that package.json file. Let's keep it open for a little bit, because we will be doing a lot of other things with this package.json. And this package.json right now is under root folder under mod.js. So now let's start setting up TypeScript first, okay, because this is a TypeScript project. Okay, so let's create a new file called tsconfig.json, and this will be in the root folder again, just alongside with package.json. This is our base tsconfig.json file. You can also name it base tsconfig.json, but for now I'm just going to leave it as tsconfig.json. Okay, and in this tsconfig.json file we will specify configuration for TypeScript. And we are using TypeScript in this project, because in this series, because the code base is going to be so huge, and also because this is a component library we will be developing first, and it is TypeScript. By using TypeScript, we make sure that the type checking is done, and we are safe of any errors and bugs. Okay, and if you are new to TypeScript, TypeScript is exactly JavaScript. Okay, there's nothing new with TypeScript. That's why they say TypeScript is a superset of JavaScript. Okay, if you go to the documentation here, so TypeScript is JavaScript. It is nothing more than a JavaScript. All it has is types. That's all it has. Okay, so the thing that you see here, this object, this is a plain JavaScript object, but with TypeScript we can add types to this first name property. So in this case, the first name is string. This plain JavaScript object is a user object that has first name, last name, and role. And with JavaScript we cannot specify types for each of these property, but with TypeScript we can say that, well, this first name is a string. Instead of hardcoding, that's string value Angela, and last name is also a string, role is also a string. So that's all TypeScript does. It provides it gives us an ability to specify types for our JavaScript code. Okay, and because JavaScript is a high level language, it's a weakly typed language. Okay, that's why JavaScript does not have type checking. But with TypeScript, it gives us ability to write types in JavaScript, just like in C++. Whenever you declare a variable, you have to declare the type of it, right? So let's say that if you declare a variable called user, then you do or maybe not user, but if you are declaring a string or variable called first name in C++, you would specify the type of the first name exactly as string. Okay, and same with numbers, you would type in int, a number is equals to 1 or something like that, but you specify the type in those strongly typed languages. But in JavaScript, is a weakly typed language. JavaScript itself does not provide type checking, and what TypeScript did was TypeScript took that JavaScript and then it added types to JavaScript. Okay, but in the end, all our TypeScript code, everything else is going to be compiled to plain JavaScript, okay? But just for the development purpose, so that we can find error earlier in the development, that's what TypeScript does, okay? So let's configure TypeScript here. The first property we'll specify on our compiler options is allow.js. We will set that to false, and this will prevent TypeScript from this allow.js property will prevent TypeScript from compiling our JavaScript files. And I do not think we will be having a lot of JavaScript files, mainly ending with .js in this throughout this project. But just to be safe, let's specify allow.js property to false. And there are some other properties that we will specify here. So allow.js set that to false, and then come down here and then allow synthetic default imports to true. I'm not going to explain each of this property because myself, I do not remember what each of the flag does, but this is the documentation for the tsconfig file. So under compiler options, right over here. So there will be many other properties we will be specifying here, but these are all the properties, okay? There are so many values. These are all the flags that we can specify in tsconfig, and I do not remember everything on top of my head. It's not possible to remember everything on top of our head, okay? So what we are going to do is I'm just going to paste all this, copy and paste everything right there in the tsconfig.json file. So these are all the brief descriptions to each of the properties, and these descriptions you can find it here in the official TypeScript documentation site, okay? So these are all the properties. There are some few important ones that we really need to discuss. After this, we set the declaration to true because TypeScript will emit the d.ts file. That's a types file for each of our TSX file or the component files. Each of the component files will have its own d.ts file, so that TypeScript can emit the declaration file. Declaration map is set to false. You can set this to true if you want the d.ts.map files, which is a source map file, like a JSON file, if you want TypeScript to generate that. But in my case, I'm specifying that to false because I do not want that. Emit declaration only, also set to false. Make sure that this is set to false, okay, for Cypress to work, because when I worked on this myself, I found that Cypress had problem when setting this emit declaration to true. So set it to false. No emit, also set it to false, okay. This is also, I don't remember exactly what it was, but if I set this to true, there was problem with Cypress, okay. So set that to false for now, okay. And all these properties, just pause the screen and read each of these properties once and read the description. There is another important one here. We will need to specify this JSX property and assign a value React to it because we are using React. This is really important. If we don't do this, things are not going to work. Some of these other properties here, other flags here, might be optional because they already come with their default value, but this is really important, specifying the JSX property to and setting it to React. And also this types property, make sure that we have all these inside that types array, okay. We have Cypress because we will use Cypress. We will need to specify React in types, React DOM, and also for the UUID package also, okay. So the base URL, set it to the root folder. Base URL / means the base URL is this mod.js folder, that is the root folder. Also specify paths, okay. So inside this paths object, specify mod.js / and this star means everything inside mod.js, include it over here, okay. So it is including everything from packages folder, which we do not have yet, but we will eventually have this packages folder just in a little bit. And then also this docs folder for the documentation sites, we will have it here, okay. So, and right after paths, exit out of that compiler options object, and let's do two things here. We will specify compile on save, and we will set that to false. we will set to false, and I have a nice little note here because when I did this, maybe I ran in through some problems, so that's why I put a note there. False, set to false, because we are using Babel, okay, and we are using Babel to compile our TypeScript code too. We're not using, okay, Babel will compile our TypeScript code to JavaScript, and then JavaScript code to older versions of JavaScript if needed, okay. But we will set this compile on save to false because we are not actually using TypeScript directly in order to compile or transpile our code, okay. And we will set the exclude property to we will specify node modules. We will tell TypeScript to ignore node modules, ignore all the files in node modules, and also ignore all the files in build folder, okay, because TypeScript does not have to look the node modules folder, and they also don't, or TypeScript also does not have to look at our production build, okay, the build folder. So that's for the tsconfig file. I hope you got a little bit of insight into what each of these does. So let's save that, and we can safely close that now. Let's keep this package.json file open. The next thing we'll do is we will, in this root folder, we will create another file called webpack.config.js, and this is the Webpack configuration for our for Cypress to work. So what we'll do here is we will require that path module from Node.js. Const path is equals to require path, okay, and then module.exports. There will be an object. We will specify a mode, and we will set that up to development because we are currently in development. We do not need to do anything here in the end too, especially when we are working with component library. But with the Next.js app, we will have a different Webpack setup for that when later in the series when we come down to it. So I will specify the entry point. Okay, so this is where Webpack will look. So path.join __ dir name, okay, and this entry point will be under packages folder that we will create shortly. Packages / there will be another folder called core, and inside that folder there will be a folder called src, and inside that folder there will be a TypeScript file called index.ts. So TypeScript is going to look at this index.ts file inside mod.js. So let's actually, because let's come to this architecture here. So inside mod.js we have two folders. One is the documentation folder, the other one is the packages folder, and inside each of these packages, I have explained this in the last video. Go and watch that video if you want to understand everything that we'll be doing, but I will be super quick here. Inside mod.js we have packages folder. Inside packages we have 4 other folders: mod.js core, mod.js icons, mod.js helpers, mod.js utils. These are each individual packages, the 4 packages that we'll be building, and each of these packages will contain all the components for each of these, okay. So let's go ahead and create this package folder, and also let's create the documentation folder for now, just so that we are consistent with the architectural diagram. So inside that mod.js root folder, I'm going to create another folder called packages. Let's also create another folder called docs, okay. So, and there is some error here. Just ignore that for now. This error usually goes away even if you restart VSCode. This TypeScript, this this error in tsconfig.json will go away, most likely, okay. If it does not, we'll figure out why that's happening. But once we have those folders, now you can see that we specify the entry point as packages, and inside these packages, let's also create another folder called core. Let's do that, core, and inside this folder let's create another folder called src. This is the source code for the core package, and this src folder will contain all the component folder, and it will also finally contain index.ts file. Okay, so now Webpack can find that file. Currently this file is empty. Let's close that. We will edit that file later. Okay, so that's the entry point. We will also need to specify output. Again, output path will be path.resolve, and this is what I was explaining earlier when I explained things about NodeJs architecture. This path module is provided by Webpack, and we can see that we are directly interacting with the computer system using NodeJs path module. Okay, and Node.js is JavaScript. If Node.js wasn't there, there might be other technologies, but Node.js made it possible to directly interact with our computer system, okay, by specifying this door name and all the file paths. So we will specify the output property, and this build folder, we will automatically, it will automatically generate a build folder for us. This is not something we do it manually. This is the final production build, but in this case we are not using Webpack to bundle our application, so this is only used by Cypress. So we will need to do that there. So let's specify file name as bundle.js, and let's do resolve, and let's provide extensions. So these are all the extensions that Webpack will need to resolve. So the main file extension is mainly TSX. Okay, this TSX file is TypeScript with JSX. Okay, that's what TSX file is. Let's also tell Webpack to resolve the .ts file, because you saw earlier we have index.ts file. That's a plain TypeScript file. Okay, and I don't think we need this .js file, but let's put that in case if we have, because Cypress, when Cypress runs, if there's any JavaScript JS files, then Webpack will resolve that too. So let's just specify that for now. Okay, and dev tool, let's set it to false. And then we'll specify a module object with, we will specify rules. And these rules will tell Webpack how to handle different kinds of files. Okay, so in test, we will write a regular expression there. So test dot, we want Webpack to be able to deal with TS and TSX file mainly. Okay, and let's put the $sign there indicating end of string, and let's indicate end of regular expression using that ending slash. Okay, so that, and we will tell Webpack to exclude node modules folder. Okay, and then use, we will tell Webpack to use a loader, and we install this loader up in package.json file in the root folder. Okay, make sure that this package.json, all these dependencies are in the root mod.js folder and not inside this packages folder or the docs folder. Okay, and I'm sure you didn't do that because we created these two folders later in the video. So let's specify the loader as ts loader, and because we have ts loader installed, right, so this will, here we have ts loader version 9.5.1. so it is telling Webpack to use ts loader in order to deal with files ending in ts and tsx. That's all TypeScript files. Okay, so that's for that's one rule. We'll also need to specify some other rules here. So that was for TypeScript ts and tsx file. Let's also tell Webpack how to deal with css files. So test colon beginning of regular expression, end of regular expression. Okay, and inside that we will put a backward slash. So exactly, so this backward slash means exactly .css file. So okay, this is going to, because dot is, and we will talk about regular expression too. There are just so many things that I feel like I'm going in super detail, but if you again if you already know these concepts, regular expression, because you might know a lot of things, even more things than even I do, but I'm trying to be really accommodating to new people that is just getting started with this. Okay, so but this dot will, because this dot is reserved in regular expressions, so by specifying backward slash, we are telling it to ignore this dot and just treat it as this everything as a whole .css. That's a file extension. Okay, and then .css, let's specify the end of string, with that $sign. This is not a regular expression course, but I don't know why I like to go deep into everything in so great a detail. But that I is going to say it's case insensitive. Okay, and this $sign is the end of string. We do not have a beginning of string here. Usually that would indicate a caret. Okay, because this CSS file .css file can, we do not know what the file name will be, but we are basically saying any CSS file use, just like we told Webpack to use TS loader in order to deal with TS and TSX file. When it comes to CSS, we will use these two packages that we installed, that we are going to install. It's not installed already. I forgot to do that. But CSS loader and style loader, we can specify this and then install everything else. Okay, that won't be any problem. Style loader and also CSS loader. Okay, so that's that. And then the final thing we will need is we will also be dealing with images in our component library and also in the documentation site. So we will again beginning of regular expression, end of regular expression, backward slash, again dot. Okay, exactly these files. So put that in parentheses. Let's specify all the files that we want Webpack to resolve. Okay, so PNG, we might have SVG file. Let's put JPG file. Let's also put a JPEG file. You can also put GIF or GIF file in there. Okay, but you can put in anything else that you want there. Let's put a $sign in the end, indicating the end of string and end of regular expression. And let's also make that case insensitive. Okay, so that even if something is uppercase or lowercase, it doesn't matter. And we'll specify type as asset/resource. Okay, and in this type here, if you are using older version of React, which I doubt you are, but you are not, because I stated earlier to you that install the same packages, same versions that I am installing, so that you do not have any problems. But in case if you, for some reason, if you have older version of Webpack, then in older version of Webpack, you would need some kind of loaders, just like this TS loader, style loader, and CSS loader to deal with the media files. But with the new version of Webpack, I believe after version 5, we do not need any other packages. Like I think there was file loader that was used to deal with the media files in Webpack, but now we can just specify type as asset, and that should be asset/resource, not asset-resource. Make sure it's asset/resource. That was a typo I made. Okay, so and let's save that. That should be all it for the Webpack configuration file. Okay, if there's any errors, we will come back to this later. So after this, let's go ahead and install all these packages, because I don't know why I have not installed these yet. But let's go ahead and run npm install. Make sure you do this in the root folder. Again, this is a mono repo. If you do not know what monorepo is, go watch my last video. It is really important. Big companies use it. Google uses it. Everybody uses it. It's the concept of monorepo I discussed in my last video. But run npm install in the root folder in mod.js. Okay, let's run npm install. This is going to give us a node modules folder in this root mod.js folder. So let's wait for that to complete. It looks like the installation is complete. It did take a few seconds for it to install everything that we specified in the step dependencies. And once that is run, you can see that there is a new folder called node modules folder. Before I jump into anything else, let's create a new file here so that we can make this structure neat a little bit. So create a new file called .gitignore. And this is not a Git repository yet. So let's come down to the terminal and let's run git init. And this initialize this mod.js root folder as a Git repository. So it is actually asking me a question. It has too many active changes. Only a subset of Git features will be enabled. Would you like to add node modules to Git ignore? Let's go ahead and click OK. Okay. And in this Git ignore file, we will ignore a few things here. So in this git ignore file, type in that node modules, and as soon as you type it in, you can see that this node modules folder is now gray colors, because what happens is when we push our code to code repository, we do not want this node modules folder containing all the packages that we installed in dev dependencies, and those dev dependencies have their own transitive dependencies, so those all will be included. If you see here, how many packages did we install? We only installed this about 30 dependencies, but if you look at node modules folder, this folder is super huge. And to look at some of the packages that we specified, let's search for Eslint. You can see that this node modules folder has a package called Eslint somewhere here. You can see this package here exists, but we never scoped, we never installed, we did not specify in dev dependency to install some of these packages. Like, what is this etag package? I do not know that. What is this ES traverse? I do not know what it does. All these other packages, these are all transitive dependency, because all these dependencies that we specified here in package.json, they have their own dependencies too. They are built on top of something else too. So that's why this node modules folder is so huge. Okay, and this node modules folder, we do not need it in production. Okay, this is just for development. But coming to git ignore, specify node modules folder to be ignored. Also, let's specify a few other things here. This is for test coverage. We want the coverage folder to be ignored. Okay, we also want the package.json file to be ignored. We also will be creating a VSCode folder, .vscode, that's a hidden folder, where we will specify settings for mainly for Prettier. And since I'm in Mac, I'm also going to specify to ignore this DS store. We are also going to ignore the build folder and types folder. Okay, so I think that's all should be it for git ignore. Let's close that. Let's close this Webpack config. This DS config, we are still getting an error, but because I think this error came in when we did not install any of these packages in node modules, and then here we specified React DOM, and UUID on the type, so that's why it's getting the error. But once you close the terminal and open it up, I think it should work. If it does not, don't worry, everything is set up very nicely here. That error will go away, and if it does not, I'll try it myself too. Okay, so now let's come to now. I believe we have most of the things set up. Let's come to packages/core. Okay, and inside this core package, what we are going to do is we are manually, or you know what, we can automatically create that, because let's come to the terminal here, and let's cd into packages/core. Okay, so now I'm in core directory under packages. So let's specify this core package as a node project too. So just like earlier, npm init, and then hit enter. And I forgot to put a -y flag in there, but I'm just gonna keep hitting enter until it gives me a package.json file. So now let me close that, this package.json file. Inside this core package, now we have src folder. Inside src folder, we have index.ts, and we also have this package.json file. So this is the actual package that will be published to npm, and there are 4 other packages like I discussed in this diagram. We have mod.js core, icons, helpers, and utils. So we will have 4 folders here eventually. But just to get this environment running, let's do these things quickly here. So for the name, this core package is a scoped package, and this core package is under mod.js scope, or the mod.js organization. So we'll specify the package name as mod.js/core, okay, and version is 1.0.0. We will specify side effects property to side effects. We will set that to false, okay. Let's put that in quote, and these are all properties. Again, if you do not know what each other property does, or if I don't explain it, go to the documentation, okay, package.json file in npm, and learn about it. So let's specify side effects to false. And before, what we did was in the root package.json, in this particular file, this is the mod.js package.json file. If you remember, we specified private to true because we do not want the root folder, the root, this monorepo, mod.js/monorepo, the monorepo package to be deployed to npm. We do not want that, but in case of core, we want this core package to be deployed to npm. So what we are going to do is we're going to set the private property in core package to be false, because we will be deploying this package to npm. Okay, so that's for the that's that. Let's also specify a files array for now, and this will tell what files or what folders to include in the production, so in the production build. Okay, so we will specify a files called build, and this build folder will be in the official npm registry. Okay, so that's for files. So this contains our build artifacts. We do not need to publish source code to npm. We are only publishing the final packet, or the production build. Okay, and we will also specify other options, so exports, and we will specify a few things here. So we will specify the required property, and we will set that to, so we will have the build folder automatically created, okay, by Babel. And so Babel build/CJS, that's for common.js /index.js. So the package that we are building, or at least for this series, the package, I want to make sure that people using common.js for importing and exporting use common.js uses require, but with ES6 we can use import and export syntax. But I want to make sure that my component library, our component library, it works both with common.js and as well as ESM also. Okay, so that's why we need to specify the exports property and specify this build/CJS/index.js, and you'll see this in greater detail when we actually run the build. You'll see that there will be a build folder inside this core folder, and inside that build folder there will be a CJS folder, and inside that there will be the main index.js file, and this index.js file is exactly the same file as index.ts file. The only difference is index.ts is a TypeScript file, index.js is a JavaScript file. This is the main file that will be used by the browser, because browser do not understand TS file, they do not understand TypeScript, they only understand JavaScript. Okay, and same thing, we will do the same thing with the ESM syntax too. So ESM syntax uses import and export in order to import a module. So we'll specify import and set that to build ESM index.js, and for require, that's again used in CJS. We'll specify build CJS index.js. So when people, if they are using common.js syntax, if they are using require, then what will happen is whenever they type in, let's say, the require button from mod.js core, or maybe let's say require accordion from mod.js core. I don't know why somebody would do that, because common.js is soon going to be not used as as it was before, but I think everybody is switching to ES6 because everything looks good with ES6. But if somebody wants to use require, they can do that, and whenever they require something from our component library, it will look under the CJS folder. Okay, this is where it will be imported from the CJS folder's index.js file. And if somebody is using import button from import link from mod.js/core, if somebody is using the ES6 syntax of import and export, then it will look under the build folder under the ESM, or the ECMAScript module folder, and inside that folder, index.js file, it will import it from this ESM index.js folder or file. Okay, so that's that. And let's also specify types. This is for TypeScript, and the types will be located in build/types/core, and this is for the core package. So core/src/index.d.ts. We do not have this file now, and also again remember, build is automatically created when we run the build. So what will happen is inside there will be a build folder here inside this core, and inside the build folder there will be this index.d.ts file, which is the TypeScript definition file. Okay, so once that, let's keep this package core package.json file open. Now let's start setting up our core package. So core src, in this core we will use Babel in order to compile all our JavaScript files. So I will make a new file inside the main core folder, not inside src, inside the main core folder. Create a file called babel.config, and we will need a Babel configuration file for the CommonJS module. Just like over here, we are dealing with CommonJS and ESM, so that our library, our component library, can be widely reusable no matter what syntax they are using. Okay, so babel.config.cjs.json, and also let's make another file called babel.config, and this is again for, just like with CJS, it's for ESM.json. Okay, so let's start configuring this Babel config CJS. Here, what we'll do is we will create an object. Inside that, we will specify the Babel plugins that we need. And over here, because we'll be using styled components for to style our application. And you might be wondering, well, where is, so in root folders mod.js, and I'm jumping things here, but where did we install React? Why didn't we install React here? Why didn't we install styled components, React DOM? Why didn't we install the main foundational technologies that we'll be using? And the thing is, we will come to this later, but we do not, in React, will not be specified in dep dependency. It will also be not specified as a dependency in the root folders package.json, in mod.js package.json, and we will come to this in just a bit, okay, if you are wondering that. But let's configure this Babel config for the CommonJS. Okay, so this will be the plugin that we'll use for this is Babel plugin styled components. And we install this, if you remember, Babel plugin style components. Make sure the version is correct. These are all latest versions from what I believe, but there might have been new minor releases, but that's not a big deal. Okay, and also specify Babel presets. So all the presets that we installed, that was Babel preset env, Babel preset React, and Babel preset TypeScript. So I'm going to specify presets there, and this under Babel preset env, make sure that you specify modules as CJS, because this is for the CommonJS, on Babel preset TypeScript, and we'll also specify Babel preset React and set the runtime to automatic. Okay, so that's for the Babel config CJS for the CommonJS. Let's also configure Babel for the ESM module. Okay, and in this ESM, again, we will specify plugin, set that to Babel plugin styled components, so that Babel can work nicely with styled components. Styled components is a CSS in JS library. It was not possible before to write CSS directly into JavaScript file, but with styled components, everything, it makes things a lot easier. Okay, and under presets, again, let's specify Babel preset env, and in modules we will set this to false. Okay, and when we set this modules to false, it is going to default to ESM module. Okay, and Babel preset TypeScript we need, and just like before with React, we will set runtime to automatic. So let's save that. So that's the Babel configuration for the ESM. Let's close that. That's the configuration for the CommonJS. Let's close that. And let's also close this mod.js. Instead of calling it a root folder, I'm going to call it mod.js, okay, just so that you understand. But this mod.js folder package.json, let's get rid of that, and let's come to this core folders, core packages, package.json file. Here we will write a few scripts. So right under scripts here, let's remove that. And the first script we'll write is we'll write a script to clean everything. So you'll see this when we run the build. So rm-rf, we will, as soon as we run the build, we will delete the build folder because we want everything to be clean. So I specify that clean script, and we will specify watch :build /esm. And there is a lot of things we're doing, but this is one of the best environment that I have set up. Everything will be so nice in the end. I was really impressed from what I did, and I spent a lot of time doing this too. It was not easy, but in the end I was super happy with what the entire structure looked like. Okay, and of course there can be improvements that can be made. Some people might not agree with me, or some people do. It's their own opinion, but from what I believe, this environment that we are setting up is a really clean environment, and these are the environments that they use in big companies and big teams also. Okay, so Babel config.esm.json. So we specified a build script, and this is to build the ESM syntax. Okay, we will have now the syntax just like before. We will have CJS too, but for now, for ESM, what's build ESM, we are using Babel to compile our TypeScript files, and we are providing the source -d, and inside the build folder, put the main production build into the build folder, and inside that build folder, create another folder called ESM, and we specify the config file that we just created. That's babel.config.esm-esm.json. Okay, and we will also specify extensions and backward slash. So the extensions we want to be able to resolve basically is ATS and TSX file, and let's put that there, the backward slash, and then we will also tell Babel to watch it, so that we do not have to run the build every single time, and it automatically runs the build whenever we make certain changes. Okay, so that's for the ESM. I'm also going to specify watch build CJS, and this will again be Babel src-d build. This will be CJS instead of ESM, and we specify the config file. So that's, I forgot a slash there because this folder is in the core folder in the same folder, the package.json, and this Babel config CJS and ESM is in the same folder. So we'll need to specify this // in the beginning. So / Babel config, and instead of ESM, that'll be CJS. And we specify the extensions TS and TSX, and we're going to watch it. Okay, so that's for the watch, and we will also watch the declaration files that is generated by TypeScript, the type definition files. Okay, so watch build and declarations will be, and for this one we will use TypeScript compiler. This is provided by TypeScript. So TypeScript compiler will look for this tsconfig.json file, and this tsconfig.json, this is not the root tsconfig.json or the mod.js tsconfig.json. This is course tsconfig.json, which we have not created yet, but we'll create this shortly. So tsconfig.json, that's to build, that's for the declaration files. So let's actually go ahead and create this tsconfig.json too. So we already have one tsconfig file in mod.js folder, the root folder. So we will need an individual tsconfig file for the core package too. So let's create a new file called tsconfig.json in the core package, and over here what we are going to do is open up a curly braces, and we are going to say that this tsconfig.json file extends this root tsconfig.json file. Okay, so extends // that's two folders back, tsconfig dot JSON. And we'll need to do this because again we are building it for the CommonJS. We are building our component library so that it can be used with CommonJS, and also it can be used with ESM. That's why we need this tsconfig file in each of the packages. And also with Utils package or core package, the TypeScript is going to be a little different. So let's do that. It extends that. So whenever we specify that it extends this tsconfig, this root tsconfig.json file, it already has all these properties, and we will specify a few extra properties here just for the core package, because this tsconfig is on the core folder. Okay, so that's compiler options. Let's set that to, we will specify a module property, and we will specify ES next here. So that is the latest version of JavaScript. Okay, so currently there is ES 2024, maybe 2025. As soon as the next version comes in, that's what ES next does. It specifies the latest version of the JavaScript, okay, the ECMAScript version. And we'll also specify output directory, and where should TypeScript send that types folder to. So we will tell it to keep that types folder inside build folder, and inside that there will be another folder called types that contains all the type definitions. It seems that there is a problem here. Maybe it's that it needs a double quote. Outer, let's specify target as well, and target will be ES next. Okay, and we will also specify a lib property and put that in an array and set that to DOM. And again, if you do not know what the flag property does, go to that TypeScript documentation and learn more about it. I do not remember what each and everything does on the top of my head because there are just so many. And we will specify the include property, and this will include everything in the src directory. So in the core src directory, okay, so we will put 2* there. So all files and folders inside src we want to include. We want TypeScript to know about it, so that's basically what we're doing. And we will also specify Cypress here, and save that file. And let's copy that, because well, we don't need to copy that, but let's save that. And then let's now come back to this package.json. Now that we have tsconfig for the core package, let's specify other scripts that will be used in the core package. Okay, so watch build declaration. I'm going to do the same for on watching too, and this will be super helpful. This setting up this environment is taking a while, as you can see, but once you set this up, things are going to be so much better for the next 5 or 7 years to come. Okay, unless things massively change. This is the this is really a good production or the development environment that we are setting up right now. Okay, so let's do for onWatch too. So, and this will all come in handy when we later on in the series. We have commands to build, we have commands to watch, we have commands to build each individual ESM or GSS or CJS or declarations. We have each of the scripts, which will be really helpful, as you'll find later in the series. Watch build declarations, or sorry, on watch build ESM. So all we're going to do here is, because we are on watching it, let's remove that. And I think there should be 2 quotes in the end. Let's also remove this from there and put on watch, and let's also on watch the declarations by TypeScript. Okay, so that's for the build scripts. Let's specify a script to run our test. So this will also run the Cypress, where we will be building the components. So test component UI, we will specify a command there called Cypress open. This will open the UI, as you see here. and this is the main thing. That's what that Cypress open command will do. It'll open this browser, okay, that is running an automated testing software like Cypress. So test component UI, we will set it to Cypress open, and we will also do test. I'm just going to call it test component, and I'll call it headless. So this is going to run Cypress outside of the browser. So what we can, the command that's needed here is Cypress run dash dash. This is for component, okay, component testing. So those are the two Cypress commands. Let's also write a command for linting, so that when we run the build, the linting is automatically done by Eslint. Let's specify that lint command. Let's also do lint fix. This is for Eslint. When we run npm run lint fix, it is automatically going to fix the linting problems as much as it can. It is not going to fix everything on its own. You still have to manually check it, but it will do some of the things automatically on its own, okay? So lint fix. Let's also specify a format script. This is for Prettier that we have not configured yet, but we will do that later. So for formatting, what we'll do is we want Prettier to format, to write, okay, and format all the files in src folder, all the files ending in js, jsx, json, css, ts, tsx, okay. So Prettier will automatically format the code. And let's also write a build property so this build property is going to include, we are going to use that npm run all package that we stored in the root. Where is that? It's not in tsconfig. In the root folder, we installed npm run all somewhere here, okay. Didn't we do that? Yeah, we did, right in the end here. Okay, so that npm, we're going to, let me close that. We're going to use npm run all, and we are going to run some of these commands here. So npm run all dash l means run sequentially, okay, or dash l means run in parallel, and the scripts that is going to run is this clean script. So this is going to clean everything up and start the build from scratch. And dash p, that again means parallel. I'm not sure what this dash L means. I think it is parallel, but I'm not sure. But basically, we are running this what's build ESM, this script. We are running this what's build CJS script, and we are running what's build declarations script. We're running these three scripts with a single command. Okay, and this is really helpful later on when you have to troubleshoot something. If it doesn't work, you want to have all these scripts right over here. Okay, and the next thing that we can do is we can also specify a pre-publish script. Okay, this is, we are not quite there yet, but this will still be used to run most of the commands or most of these scripts if we want to run it all at once, if we want to test that the component, everything works in the component. Let's specify that. So this pre-publish is going to use npm run all. It is again just like before. It is going to run it sequentially this time. So this is what I was talking about, having all these scripts. You can see the difference here. We are running all these scripts here. So we are first running by using -s flag. We are first linting the code. We are then formatting the code. We are then running all the test component headless. So this is the script, this pre-publish script we will run before actually deploying our component to npm. So we will need to run this sequentially so that all the linting is done first, and then formatting, and then test is run in a headless environment outside of the browser. And we're going to onwatch this onwatch build ESM. We're going to onwatch the build here. That's why you specified this onwatch script, onwatch build ESM script. And the same thing, we're going to onwatch build CJS script, and then we're also going to onwatch build declaration script. Okay, and because if you do not set this onwatch here, then what's going to happen is when you run npm run pre-publish, it is going to maybe run this onwards build ESM, but it is going to stop right over here, because if we are watching it, it is going to keep watching that ESM and none of the other scripts get executed. Okay, so that's the difference. And over here, since we are running over here in this build script, we are running everything in parallel, and this is helpful while we are developing the component. So this is going to run everything in parallel so that it is not going to stop at one of these scripts. All the things will be built. Okay, so that's, and you'll see this in greater detail as we keep working on this, but I think that's all we need for the scripts. Let's specify these peer dependencies, and I'm going to explain what this does. So in peer dependencies, we will specify, now this is where we will specify React, because as I stated earlier, if you come to main package.json, we did not install React, we did not install React DOM, we did not install style components here. We only installed Babel's plugin style components, but we did not install style components. So this is where we will specify React, and let's do this first. I'm going to specify these main three things that we'll be using. So React DOM, and style components. And again, make sure the version is correct. This is, I believe, is the latest React version 18.3.1, and this I believe is the latest style components version 2, 6.1.11 as of today. Today is July 18th of 2024. But as the series goes on, and these components that we're going to build, I'm going to use it on my own website, on my own project. So this will be probably like a never-ending series. As soon as I make new components, as soon as I do something new, I'm going to come to the series and keep making videos about it. Okay, but this peer dependencies, what it does is we're specifying this React DOM and style components as peer dependency and not as dev dependency, or not as dependency. We're specifying this as peer dependency because the end user using our component library, they will have their own version of React installed in their application, in their in their computer. They will have their own version of style components installed in their project, same own version of the React DOM installed on their own project. So that's why we specify this as peer dependencies, because we want to use whatever we want to use, the React version or the style components version. We want to use that version that the client installs, and we do not want to specify any of our own version, because if we don't do this, then if you are familiar with this, React will give you an error saying that there are multiple versions of React running in the same application, and that error, that is an error. It is not a warning. If that error happens, the things don't work. So make sure that you specify this as peer dependencies. Okay, and as we continue to work on this, I am sure we'll come across that problem. But for now, let's specify these three packages as peer dependencies. And for the core package, if you watch my video about the architecture here, I stated before that the core package is dependent on the help us package. So we will come back to this package.json file later when we are actually dealing with all the other packages too. Okay, but for now, I think this package.json file looks pretty good. So the next thing we'll do is in core, let's configure. So we're getting closer to writing or opening up Cypress here and seeing the UI. Let's create a new file called Cypress. So we are going to finally configure Cypress here. Cypress.config. This will be a TypeScript file. And over here, so this one, we will import, or I will just copy and paste that. So we're importing define config from Cypress, and we are setting the viewport width. So this is, if you are wondering what we are doing here, we are setting, so when we specify viewport width to 769 and height to 600, what we are doing is we are specifying this viewport here, this white big white thing, the window that you see, that is the viewport. So we are specifying the size of viewport. And for component, we are specifying a spec pattern. So all our test files will end in .ts or tsx extension in the core package. This will change when we jump to other packages. But the dev server that we are using a framework React. And over here, we are specifying bundler and setting that to Webpack. Okay, that's why we needed Webpack in order to run Cypress. You could run Cypress with something else too, something like Next.js, but this is not a Next.js component library. It's a React component library. Okay, Next.js is something that we will use to build a documentation website or app later in the series, but for the components, for the component testing and component building, we will use Webpack and framework React. Okay, so let's save that. And so I think I covered everything up. Let's go ahead and create our first component. Okay, so we want to go to src folder, okay, and create a new folder called components. And inside this component, I'm going to create again a new folder. Let's create a typography component, or typography folder for now. And inside that typography folder, I'm going to create a file called typography.tsx. This is a TypeScript file with JSX. Okay, and in this typography.tsx file, let's build out a simple typography component for now. So what we can do first is we can import React from React. Okay, and let's declare that const typography is equals to, let's also import styled from styled components. Okay, this is going to let us style the h1 tag that we'll be writing soon. So import style from styled components. Okay, so typography is equals to styled. I'm going to call this mod typography because that is my naming pattern for the entire project. You can name it something different, but styled dot, I'm going to grab the h1 tag, and then just for the simplicity here, I'm going to specify a color as a nice green color, 586bit31, and let's declare the typography component now. Const typography is equals to that, and then we will just return this component, this mod typography component. We will come back to this in greater detail when we're actually writing the typography component, but for now, just to show you that we can open up things in Cypress and start building this application, that's why I'm doing this. So mod typography h1, or mod typography, let's close that tag there, and let's type in hello. Okay, so let's do that, and let's export. We will default export that typography component. Okay, something happened here. That should be typography. So let's also include some TypeScript thing here, because we install TypeScript. We want to make sure TypeScript works. And we will come, let's declare a interface, TypeScript interface mod typography props. That's what I'm going to call it. And I will explain each and everything in greater detail, all the things about code. But let's just make this development environment going, because I feel like I spent too much time on this. But mod typography props, this is going to take children. Okay. And this is going to be a React node. Okay, so what this is doing is, and let's again specify types here. Let's destructure that. Let's put that children there, and then let's specify types. So that's mod typography props. So this typography component, what we are doing here is we're importing React. The first thing first, let me explain this code a little bit. We're importing styled from styled components in order to style our typography component. In this case, the typography component re-renders or displays on the screen an h1 element on the DOM, and on the screen it'll display a big heading, okay, with a color of this 586bit31, which is a greenish color. Okay, so and then we are using TypeScript in order to define types for this. So this TypeScript component will take children, and that children, it could be string, it could be object, any other things. Well, it cannot be object, but it could be string. But in this case, we are actually supplying React or React Node. So this children property is going to take React Node as a children, and this is the React Node. This hello is basically this mod typography, this everything else here is this hello is basically just the React or React Node that is wrapped inside this S1 tag. Okay, so let's save that. And let's try running this thing up and see if it actually works. Okay, so let's close that, and we will come to this. Let's try to run some of these scripts, and for now, let's just to make sure that everything works, we're in the right track. Go inside the core. I believe you are already here, not in the root folder, root mod.js folder, because in package.json we do not have any scripts yet. So let's first run this script from the core package. So what we're going to do is we're going to run npm run in the core directory. We can run, let's try to run npm run build. Let's try to build that typography component and see what errors we get. Exited with one unknown option extension, so there is an error here, and this should have been extensions. So change that to extensions and not extension. Change it to extensions with an S in the end. So let's run the build again. And it did run the build, but we did get some errors here, unknown option plugin. And well, we'll come back to that later, but it did run. Okay, so when we ran npm run build, and this is Babel is doing this magic here. So Babel is running this Babel config ESM, Babel config CJS, and it is also running this TS. This TypeScript is also running this watching this TS config.json file and running and giving us a declaration folder, which we will see here if everything went right. So inside this core folder, as we ran the build, you saw a build folder, and inside that folder, just like we specified, inside the build folder, there is ESM folder, and there is also CJS folder, which it looks like everything is the CJS and ESM is blank, but the TypeScript types folder, as you can see here, this is done by TSC, this TypeScript compiler. Under components, we have that typography folder, and inside that typography folder, we have typography.js file. So this is the typography component. This is the production typography component that will be deployed to npm. And again, because in tsconfig.json, we said that we want the types to be right beside the component. So that's why there is this d.ts file. Okay, and you can see that we wrote, so let's come back to the original typography.tsx file. You can see that we wrote this in TypeScript. We specified the types, okay, even though if it's a very simple code here, that is all it is doing is rendering trying to render an H1 element with a color green. But this is our source code. This is our source file. This is our source code that exports a typography component. And you can see when we ran the build, everything is converted to JavaScript. There is no any types. Okay, and this well, I should have put like children here instead of hello. That's what I meant when I said React Node. Children, we will need to specify children there, and we're going to use this typography component soon here in Cypress. Okay, so change that to children. We are trying to render a children with with typography component, and this children will be a React or React Node, and this will automatically render a H1 tag. Okay, so what I mean here is we wrote our source code in TypeScript, and then when we ran the build, Babel did the magic here. It looked at the config ESM JSON, config CJS JSON, and then or not Babel, the TypeScript compiler did the magic here, and then it converted our TypeScript code in typography component into a plain vanilla JavaScript. Okay, so that's for the typography component. So now let's actually try to use this typography component. Okay, there is nothing popping up here quite yet, but what we are going to do is inside this typography component, we will create a test file. Okay, this is the testing we are doing. We'll create a file called typography .spec.tsx. So this is for Cypress. So now let's write a simple test for this typography component and see what happens. So in this typography spec file, so spec file is spec also means test, so some people name it typography.test.tsx. In case of Cypress, it's better to use spec so that we can see that it's a spec file or a test file. We will write some test here. In this simple test, all we'll do is we will render that typography component. Okay, so let's import React from React, and let's also import that typography component from typography. And remember, we are this typography spec file, and the main component file is under typography folder. So we'll have tons of folders, over 100 folders inside this component folder. Right now we have a typography folder. Later on we will have accordion folder, drawer folder, code editor folder. We will have all these folders here, but for now, just for the just to make sure that this environment works, let's import that typography component in the spec file. And what we can do is we will write a describe block. Okay, and if you just click on that describe, we will call it typography. I just want to quickly make sure that the environment works well, and we will write a it block saying that it's a render typography component. Okay, and then we will use cy.mount. So this is cypress.mount. All it is doing is we are going to mount that typography component, and we're going to write some random text here. I'm going to copy this lorem ipsum text and then write it there. And we're going to save that. There is an error saying that mount does not exist on type cy and cy event emitter. Let's leave that for now. Let's see if this runs. All this mount function is basically doing is it's like mounting your phone holder in the car dashboard. We are mounting this typography component onto the screen. Okay, so let's try to run. Even if there's an error, we'll see what we get. And we're still in the core directory. We will change this later on. We will run everything from the monorepo, from the root directory. But for now, just to test that this works, in under core, we will run the script that we specified for Cypress. So test component UI, that is to open up the Cypress UI. Okay, so we will run npm run test : component, because this is component testing. When we have end-to-end testing, we will write a different script for test E2E UI. But for now, since this is a component test, not a complete one yet, but let's run that test component UI and see what this does. It will say it looks like this is your first time using Cypress, and it did open up Cypress here. Let me see. It feels like it's on the other screen. Let's run that again. So it looks like Cypress verification timed out. There is an error. This command filled with following output. I'm not sure what that means. DevTools, listening, server, coding is stable REPL. Let's try to run it again. I am not understanding well, there was any errors, but as you can see, I did not make any change there, but I just had to, I don't know what that error was before, but you can see that when I ran test component, npm run test component UI again, there's this nice UI that popped up. Okay, and inside this you will see a screen, because you'll see two of these big boxes. One box is for E2E testing, the other box is for component testing, and we are in this series, in the beginning we are doing a component testing first, and then later on, well, at the end, when we progress with the series, when we work with the documentation website, we will do end-to-end testing. Testing is a big topic. Maybe I will make a new video about everything that I know about testing and everything you need to know about testing for this series. At least I will probably make a new video about testing, but for now just understand that end-to-end testing is to test the and it actually explains it over here too. Build and test the entire experience of your application from end to end. That's the word here. We are testing our entire website as a whole. We will test. We will tell Cypress to visit this URL. We will tell Cypress to check if a certain link is broken or certain link is working. So will probably visit however many pages we have in that particular app. Maybe we have 10 pages in that app. We'll tell Cypress we will write end-to-end tests in order to test each of those pages in greater detail. Okay, that's for end-to-end testing. That's not what we are doing right now. At this point in the series, we are doing component testing, and you should see a button here, or not button, you should see that it will say configured, and it will be in green, because over here inside the core, we already wrote the Cypress config.ts, so the configuration is already done. Okay, so that's why you will see the component testing. On a component testing, it will say configured. So let's click on this, and we have an error, Cypress configuration error. So it says your project does not contain a default support file. We expect a file matching Cypress support component JS, JSX, TS, TSX to exist, and if a support file is not necessary for a project, no, this is necessary, so we will need to set this Cypress folder up. Okay, so when we ran the Cypress command, it should have set up a Cypress folder for us, but it did not. So what we can do is we can manually, this would have been automatically created by Cypress, but it did not. So this is not that hard. Under core, let's create a new folder called Cypress, and inside the Cypress folder, we will create a folder called support. This really should have been automatically created when we try to open up Cypress, but maybe what happened, well, you know what happened? No, it did not create this automatically, this Cypress folder, this Cypress support folder automatically, because what we did was we created this cypress.config.ts file earlier, and we specified the configuration. So that maybe that's why I'm thinking maybe that's why Cypress did not create this folder. If we had not specified this cypress.config.ts file, I'm sure Cypress would have created this Cypress support folder automatically. Okay, but that's not a big deal. You know what? Yeah, let's actually just do this. Let's tell Cypress to create it automatically. So let's delete that Cypress config.ts too. There's not a lot of files that needs to be created, but I just wanted to show you that Cypress should have automatically created it. So now we do not have the Cypress config file. So now let's run this script, npm run test component UI. So when we run this, it is going to ask us what we want to configure, and well, this was beneficial too, because before you saw that this component testing was already configured because we had Cypress config file. Now we deleted that file. We do not have that. It is saying that nothing is configured here. So let's go ahead and configure component testing. Okay, so project setup. Yeah, this is what I should have done before. I was too smart, and then I made the Cypress config.ts file, but then I think this is better to do it like this so that you know how Cypress works. So Cypress is asking us to set up a project. It is automatically detecting that we are using React, is detected, front-end framework, and bundler. It is because we have this webpack.config.js file. It is also automatically detecting this Webpack. Okay, so let's click on next step, install dev dependencies. So we have everything installed. We already did this. We installed Webpack, React DOM, and TypeScript. Okay, so let's click on continue. So see, as soon as I hit continue, it created all these configuration files, and now Cypress automatically created this folder. Inside that folder there is fixes. Inside that folder there is also support with these 3 files that will come back to later. And it also automatically created this Cypress config.ts files for us. Okay, so we did not have to do this manually before, but that's okay. And in this folder, in this file, we will revert back to the previous code. So viewport width, we will set that to 769 pixels for now. And this is the global settings, right? So every single test cases that we run, every single test suite will have a default viewport width of 769 pixels and a default viewport height of 600 pixels. This is the global configuration, but we can always change this if needed in each of the test cases too. Okay, and let's also specify, I think we had a spec pattern that we specified telling Cypress what are the test files that it needs to look at. So in this case, spec pattern is inside the src folder. So Cypress config is going to look our src folder inside the core folder, or the core package, or the directory, whatever you want to call it. Inside this src folder, we will need to look at all files, including this .ts file and also this tsx files. Okay, so but in this case, Cypress is mainly going to look at this spec.tsx file and not any of these files. So let's specify under src folder, I want to say look everywhere, and everywhere if there exists a spec.ts or tsx files, I'm telling Cypress to Cypress config to look at it, and then it will automatically look at our test files and then run. So now let's try to run and see what we get. npm run test component UI. Let's run that. It's already configured. And then we are getting another error here. Your config file threw an error from cypress.config.js. So there is some error here. Does it say what error there is? Invalid configuration object. Webpack has been initialized. Should be one of these null undefined object. So after trying to debug this for a little bit, I tried to see what was going on, and then I got stuck on this for a while. But let's come and make a few changes here in our webpack.config.js file. Okay, and over here in this exclude, we will put a slash there. So this is like this is regular expression. We're trying to exclude node modules folder from it. So let's see if anything changes. Let's try to run that again and see if we still get that error, which I'm sure we will get it, because there was this concept of monorepo that I explained in last video. But no, everything worked. No specs found. Everything did not work, but something worked here. We got rid of that error, and that was because of this exclude this node modules. Before we put node modules in quote, now we put it like that. Okay, so make that change, and then there are tons of windows opening here, but this is the spec, but it did not find any spec. We did create a spec file, okay, in spec.tsx, typography.spec.tsx, we have that file. And then in Cypress config, we said that the spec files are located under src folder, and inside that src folder there is a file ending in .spec.ts or tsx. Let's remove that space there. Maybe that's why it's creating that problem. Let's try to run this test again after removing that white space from right here. See if Cypress can find our spec files. and it did. So there was another typo that I made, that there should not be white space there. Let's remove that white space. So let's save it, and then let's open that up. And then you can see that Cypress has detected this typography.spec.tsx file. Let's open it. And then the typography component is being mounted. You can see it's working. We specified the typography component to have a color green. And Cypress is automatically Cypress is mounting that typography component. Let's try changing this color to red, okay, and see if it builds automatically. It did. Cypress ran it automatically, and then if we come to Cypress here again, we see that the color is green, so that the typography component is working. So this is where we will be writing all our where we will be viewing our component, and where we will be writing test for our component, okay, for all our components. So that's the Cypress window there. There are a few other things that we need to do because this CJS folder, nothing is appearing here. Even in ESM, there's nothing here. We need to fix that, and there are a few other things that we need to do. But for now, Cypress is working. Okay, so let's close some of this tab here, and we will keep optimizing all of this throughout the series. If you are looking for a one video that does all the optimizations, I'm not sure if I am able to do that, but we will do this as the series goes on. Okay, there are a lot of optimizations we can make, but for people that are watching how to just set the environment up, let's also facilitate. I want to facilitate you guys out there, and at least get the development environment robust and going. So the next thing we will do is, if we come to this typography .tsx file, if I add some white space there, it is automatically formatting it in my case because I already have Prettier installed. So let's go ahead and deal with Prettier and Eslint. So with Prettier, it is already formatting it, okay, but I will help I will show you how we can set that up too. But let's add a console log statement there, and let's just type in printing. So this is for checking for Eslint. Right now, it's not giving us any error, any warning, because we have not configured Eslint. But next, when we configure Eslint, this console log will appear as a warning, and we will have a yellow stroke line right on the bottom saying that we have a console log in our component, which we do not want in production. So let's go ahead and set up Eslint and Prettier. Let's go ahead and set up Prettier first. So in order to set up Prettier, the first thing we will do is go to this extension tab, click on extensions, search for Prettier. Okay, I already have it here because I already have it installed, and install this Prettier code formatter. I already have it installed, but install it. Okay, so that's for Prettier, and also go ahead and install Eslint. I already have it installed. Go ahead and install this Eslint extension. So once you have those two installed, we will set Eslint and Prettier up. So let's set up Eslint first. So in order to set up Eslint, what we're going to do is, in the root folder in mod.js, we're going to create a new folder called .vscode. This is the hidden folder. Okay, and inside this .vscode folder, we will create a new file called settings.json, and that should have been settings. And inside this settings file is where we will specify settings for both Prettier and Eslint as well. Okay, so the first thing we'll do is we'll specify Eslint .experimental .use flag flat config, and you can go to the documentation and see what all this does, but we will set this to true, and this will enable VSCode to show us the errors and warnings in the editor. That's why we set it to true. Okay, and the next thing we'll set up is Eslint our editor, and this is VSCode settings. Okay, code actions on save. So we will specify what VSCode need to do when our code actions on save. I'm not sure, I don't know what I'm saying there, but we will do source dot fix all, and then we will do explicit. Okay, I'm not sure in greater detail about what all this does, but I know it works, and that's all I care about right now with Eslint and Prettier, because I do not want to learn those. It would be nice to learn those technologies in greater detail, but all we want is our code to be consistent, and we want to get the component and websites done instead of setting up the environment all day and every day. Okay, so let's do that, and here we will say TypeScript, because that's what our code base is based on. So TypeScript, and we'll do editor dot format on save. Okay, we'll set that to true, and this is setting true for all .ts files. Okay, we are telling VS Code to use Prettier, or not Eslint, but Prettier to format all files ending in ts, and we are setting it to true, so that will format all the .ts file. And we'll also need this editor dot default formatter. So this is where we will specify what the default formatter is. In this case, we are using Prettier. We already installed that in mod.js root package.json file. So we will specify ESBENP. I don't know what that is. It would be nice to have take some time out and learn about that, but that's okay. You set this up, ESBENP.prettier-VSCode. So for TypeScript, that's all. And we are also using React, so we will do this for TypeScript React also. Okay, and let's just copy this and paste there. Editor.format on save, set to true for TSX files. So this TypeScript was this object here is, with TypeScript, this was only for .ts file. This TypeScript React, because when TypeScript is combined with React, we name our file ending in .tsx. Okay, so for .tsx file, we are again setting format on save to true. And let's go ahead and do the same thing for JavaScript also, in case if we need to write any plain JavaScript. And then for JavaScript, we will do the same thing also. I guess this could all be combined in a single object, but I don't know why that's there. Let's remove that. And JavaScript. And also let's do the same thing for, just like with TypeScript React, let's do the same thing for JavaScript React also. So JavaScript React, we have the same thing, and this is for JSX files. Okay, so this is, the first one is, as I said, is for TS files. TypeScript React is for TSX files, for Prettier to format our code. JavaScript is for .js files. Prettier will format our .js files, and Prettier will also format our .jsx files. That's for JavaScript React. Okay, and let's do editor.scrollbar. I'm going to set this vertical scroll bar size, because when we have a lot of components running, there are a lot of components that needs to be built, so that this scroll bar size we are setting it to 14 right now, but this is it'll just make this terminal a little more big. As you can see that we cannot scroll anymore on top. Besides that, this is the topmost point here, but if we specify the scroll bar size, we can scroll up even more just a bit, okay, just so that we can see if there's any errors while running the code. So that is for the VS Code settings. So let's save that. And I am not sure why this is faded here, this first line, but let's try to set something up, and let's go with Eslint, and then if there's any errors, we'll come back and fix this. Okay, so in order to configure Eslint, we will not need to do this in monorepo in the root folder in mod.js, so that all the packages inside the packages folder, all the apps, Next.js apps inside docs folder later on in the series, do not have to install all these packages in each of these, or all these dependencies in each of the packages folder and each of the docs too. So that's the concept behind monorepo, and I explained that in earlier video. If you have watched that, you should have known it by now, but only thing we are doing is we have a main monorepo mod.js, and inside that monorepo we have all the dependencies that every single packages or apps in our monorepo will automatically inherit these dependencies from the root folder, mod.js folder, or the monorepo. Okay, so let's close that. Let's close that for now too. Let's do that. And the next thing we'll do is let's set up Eslint. Eslint.config. This file should end in mjs. That means it's a common JS file. If we do not specify mjs extension in the end, it is going to give us an error. Okay, so over here what we'll do is we will import TypeScript Eslint, and we will import this from the TypeScript Eslint package we installed earlier in this video. Where is that? Here, TypeScript Eslint. Let me copy that. So that's from TypeScript Eslint. We will also need Eslint JS from, and we already have Eslint installed, so we can directly import that from eslint/js. And we will export default and array. At the beginning of the array, we will use that Eslint.js package that we imported on top, and eslint.js.configs.recommended. Okay, so what this is going to do is for all our JavaScript files, which we will not have that many, but just in case if we have any, then Eslint is going to apply the recommended settings for the JavaScript files. Okay, so that's for Eslint JavaScript. Same thing we need to do with TypeScript Eslint also. So TypeScript Eslint.configs.recommended. Okay, so again, this is for all the TypeScript files. Eslint is automatically going to give us the recommended settings. Okay, so that we do not have to configure each and everything. We will only configure what we want right in this right over here. So in this object, I will create a new object ignores, and this will ignore. There are a few things that we want Eslint to ignore. So it will ignore all the files inside node modules. It will ignore the files inside packages, core, every single files in the build. This is for production. We do not want Eslint to be messing up with the files in here, because if Eslint messes up with the files here, there might be errors in production. So we want to ignore the build folder completely, and we also want to ignore this .d.ts files if there are any, which there is in this types folder. We want Eslint to ignore those. Okay, and let's come down here and we will specify the files that Eslint should look at in order to tell us if there's any errors that we made in this in all these files, in TS files. So let's also specify TSX files there. And just to be safe, let's also specify JS extension, and let's also do JSX. So let's put a comma there, and we will specify some rules. So this rules object here, it is going to overwrite every single thing that's recommended here. So what we're doing is we are still pulling out all the recommended settings from Eslint JS and for Eslint TypeScript, but there are some rules that we can override. So what we'll do in this rules is we'll set, and let's do this first because we talked about not having console log in our this typography component. I keep closing that, but we do not want that console log to be in production. We want Eslint to warn us if there's console log. So we will set the rules here. So I set the rules to no console, set it to warn. And we can also set this to off. We can set this to error. But for console log, I just want Eslint to warn me about it. And there are lots of other rules. Go to the documentation and then specify whatever you want to want Eslint to specify. But there are a few other rules that I want to add here. I'm just going to copy and paste. So for TypeScript, because TypeScript and Eslint, they have some, they actually have a lot of conflicts because there are some things that TypeScript does and also Eslint does. So in order to get rid of those conflicts, we can specify some rules here. So from TypeScript Eslint, we are saying no var requires, we're setting it to off, no unused vars, we're setting that to warn. So let's say that if there's any, so let's say that if I declare a new variable called, I'll just say unused var is equals to, let's set that to a. If I do it like, let's set that to 1. If I do it like this, right now, this is not used anywhere out in the code. This is just random stuff that's sitting up in our code base. So we do not want this. We want Eslint to tell us, hey, you have this unused var that is set to a number 1, but it's never used. Why do you have it there? The code base, the code is just getting, it's just creating a clutter in the code. We do not want it here. So let's keep that here for now. So when we specify no unused vars, Eslint will give us a warning in this case, saying that there is no unused vars. And same with this import. So this is really helpful when we have, let's say that I want to import something completely that I don't need. Maybe I want to just import maybe youth state in here, which from React. And this youth state is not used anywhere in this code. So what Eslint will do is just like with unused var, Eslint will give us a warning saying that, hey, you have youth state imported in your typography component, but it's never used. Okay, so correct that. So so Eslint will automatically warn us about that. And there are a few other rules that I wanted in my use case to be specified, so that's why I have it there. If you want it, put it in. But I recommend you put it in so that we are in these. We have the same code base, so that if you run into errors, you can come back here and then see what happened. Okay, there was this one thing that I wanted to talk about, this no undef. I have set it to off. This is when we will work on the documentation website when we are working with local storage. We will come back to this in greater detail. Like when trying to save the theme in local storage, there was a problem, so I had to set this off in order for the Next.js app to not show any errors whenever I use local storage. But we will come back to that later in the series. But for now, let's save this Eslint configuration and see if what else needs to be done before we actually start getting warning and errors in this code here, because we have this unused var and we also have this youth state that is not used. Okay, so that should give us an error or a warning. So let's also write the configuration for Prettier as well. We wrote the configuration for Eslint. Let's do the same thing for Prettier. In the root folder, I'm going to create a new file called Prettier dot, and this should again also end with MJS. This will be writing this should end in MJS. Let's for the Prettier configuration, I'm only going to specify a tab width of 4 semicolon. I do not want semicolon in my code, so there is this semicolon here. So I want Prettier to automatically remove the semicolon, so that's why I set it to false. Single quote to true. All our parents I set it to void, and these are for if there is only one parameter that is wrapped with a parenthesis, then it will just remove that parameter. So that's all the Prettier is doing here for now. But let's set that to this for now, and let's close that. And let's come to Package.json, because we have specified in core, or yeah, in core package.json file, we have this lint and format script. So let's try to run this and see what this does. So npm, and this would be in core, so make sure you go back 2 folders back, and in the root folder, oh no, you know what, this is actually in this is in core folder, in the core package. So let's run npm run, let's try to run format first. Npm run format, it formatted it, so let's go back to that typography component, and you can see that Prettier did remove that semicolon there, but I think it would always remove it, because yeah, no, it's still not. Okay, so that did remove that semicolon, because if we run this thing again, npm run format, it should remove that. Okay, and same thing with Eslint. So let's try to run Eslint. Is, well, hold on, before I do that, it is formatting it automatically, huh? Because I'm not sure if this is what you will see auto formatted, because I want to make sure that your Prettier setup works well too. But mine, I have Prettier set up in all my projects, so it automatically did that. I do not have to. Most of the time, if it's still not working for you, if Prettier is not working, try closing this VS Code and try opening the workspace file again, and then it should do it for you. If it doesn't, can you let me know down in the comments below, because I ran into a lot of problem configuring Eslint and Prettier on VS Code. It's really popular, but there are just so many errors that happen. Something doesn't work. So if there's any problems you are facing with this configuration, can you let me know down in the comments below, because I want to see what other people are facing as well in regards to this. But in my case, if I want to format using Prettier, I want to remove the semicolon as stated in Prettier config. I have semicolon. As soon as I hit save, that does not do anything. Okay, but if I run npm run format, that did do it. So what I'm going to do is, I'm going to, because we have Eslint set up, we have Prettier set up, I'm going to shortly take a short break here, because I've been up since 4 a.m. in the morning, and it's already 12 o'clock, and I still have a long day in front of me. So I'm going to take a short break here. I'm going to close this VS Code tab and then open up, and then see if these Eslint warning are showing up. So I'll be back shortly. Okay, so all I had to do was close VS Code. I took a short break. I drank some water. I drank some coffee, and I'm woken up again, even though I'm really tired. But all I had to do was close VS Code and then open it up again, and you can see that the Eslint is throwing a warning saying that use state defined but never read. That's exactly what we wanted Eslint to do. Same with unused var, it is giving us a warning. Same with console log, it is now giving us a warning. So Eslint is working in my case, in my environment, but in your environment, I'm sure it's not going to work in the first attempt. Okay, and this is where Docker and containerization, all those concepts come in, which is not a part of this series, but I will try my best in order to get this working for you too. So there are a few things, because I write in my computer, everything is set up, so maybe that's why it's working on mine. If it doesn't work in yours, then there are a few things that we need to do. So let's come to this root package.json file in mod.js. Here there are a few properties, or one workspace property, which is a very important property that we need to set, because we are working in a monorepo architecture. Okay, and that's because if we let's go ahead and set this workspace property first, and then I will talk more about it. But npm has a property called workspaces, and this is where we will define our workspaces. So in this case, our workspace is, I explained this in a lot greater detail. I keep coming back to this diagram. That's why this part 2 of the video, the last video I posted, is so important in order to understand this concept of monorepo. Okay, but in this workspace, our workspace is basically, so mod.js is our monorepo, and all the folders that we have here, the packages folder, documentation folder, and this packages folder has all these 4 individual packages. This documentation folder has all these 5 Next.js, 4 Next.js app, and maybe 1 Create React app. I talked about microservices in the last video, but these are the workspaces. So these packages and documentation and all these individual packages inside it are workspaces. So in package.json workspace property, we will need to specify that. Okay, and just to be more clear, I'm going to specify each of the packages. We will specify each of the packages, and then later on, once everything is ready to be built and deployed, we will change this so that we have that slash asterisk, so that it takes in it includes every single thing under mod.js folder. But for now, let's set the workspaces to packages/core. And this is if the Eslint of Prettier is not working. Try this, it will work. My system works. Okay, in this everything that we have set up now, it should work. If it does not work, there is no way it should not work. If you have everything same as mine, it should work. Okay, so for now, let's set that workspace property, set it to packages/core, and set that up, and close VSCode, try reopening it again, see if it works. It should work. Let's do a few more things. These are all optimization things, and again, when it comes to monorepo, we do want to do that. So let's come to core package.json just to verify that everything is good here. We will, in this, the reason we do not have this build folder, the CJS and ESM folder is empty, is because we will in our core package.json file, we will need to specify the main property, and this is going to point to that build folders index.js file. So there are a few things that is left to be done here. So build/cjs/index.js file. We do not have this file yet in the build folder, but we're trying to fix all those issues there. Okay, so let's specify the module property, and this is for ESM. This main is for CJS, this is for ESM. So build/ESM/index.js, and also let's specify types. Okay, so for this types, we'll do build/, and that's under types. We already have this types folder in build folder, you can see. So build/types/, and because right now we only have one package, but this is eventually going to, we are eventually going to have 4 packages here. So core, utils, helpers, and icons. That's why it's really important that you watch this previous videos so that you understand the entire architecture. Okay, but for now, let's set that to course src, and inside that we'll have index.d.ts file, and the private is set to false. That's good for now. We also have we can remove this main property here. There's now the main property, so let's remove that because we already have this main here. Okay, so that's that. Let's check for, we're trying to figure out why these are empty here. Let's check to make sure that we have all the scripts correctly. So Babel src-d build esm config file is Babel config esm.json, extensions is tsx, and watch, this is the problem here. I forgot I have a white space there, and I also forgot a period in there. So let's put that in there. Okay. There should not be a slash there. So .ts, comma, period .tsx, and same over here, .ts, comma, period tsx. That is going to, Babel is going to watch all the ts and tsx files there. Okay. So this tsconfig, it is already doing it. TypeScript is building that types folder for us. And same thing over here. Let's correct that to ts, comma, .tsx. And this is also ts, comma, .tsx. So let's save that. Same thing for onWatch. We're not even running the onWatch right now, but let's correct that one too so that we don't have any problem in the future. So we have Cypress. This Cypress is already running, which is good. Linting is also running. Lint fix. Let's try to run this script and see if it actually fixes this linting error. But this is inside core, right? So let me open another tab there so that I don't have to keep writing this all over or keep switching it manually every single time. But let's run npm run lint fix. I'm not sure if this is going to fix it because Eslint cannot fix everything on its own, but when I do lint fix, it is not fixing it, it is giving an error. But maybe later down in the series, maybe there is a way to automatically remove this, which I would not want to do that. I would want Eslint to give me an error, and then I will manually go and correct those. But there might be some use cases where you want Eslint to fix everything automatically. So I think that's good for now. I do not want Eslint to fix everything automatically because there might be some things that's absolutely needed, and Eslint fixes it, and if it does not fix well, then there might be some problem. Okay, but what happens if I run npm run lint? This is going to run Eslint. This is going to run the exact same thing as Eslint with this fix flag here. But there are some differences. Fix can indeed fix some of the issues, but in this case, it is not doing it, which is good. It's just giving us a warning. Okay, so that's for the package.json. For peer dependencies, we have this. I think that should be all right for all these scripts. So the next thing we'll do here quickly before I wrap this up, this has been way too long already, because we are using a monorepo architecture. We want everything to be run from this root mod.js folder. So even to run this, let's say in core package.json file, if I wanted to run npm this test component UI, and right now I would have to run it from the core package. But we want to make sure that we have one monorepo that is mod.js, and we can run each and every single script from within the root folder or the monorepo. Okay, it's a single repository to manage every single packages, every single apps within that monorepo. Okay, so let's set this up. So in package.json core, let's keep that open. In the root package.json, let's finally write some scripts in order to run some of the these core scripts. So what we can do here is under scripts in this root package.json file, let's write a script. This is not absolutely needed. This dev test server, this is going to run Webpack. But we do not need to do this, but I'm going to include this for now here in case we want to run the Webpack dev server. But in our case, Cypress is already doing that automatically, but I will just keep that in there in case if I have to run this particular script. And then we will also write a script in order to build our core, right? Right now, these folders are empty. In our core package.json file, we have a build script. All these are a build script that is building using Babel. So we will write a build script, and then this build script will be, the script will be build colon core, and then we will run npm run build. Okay, and this is running build from the workspace mod.js core. So that's why in root folder, when we specified workspace, this is also one of the reasons why, because we want the monorepo to be able to see each of the packages inside that monorepo and also each of the scripts within each individual packages. So this build core is going to run npm run, and this particular command here comes from this core package.json file. There's this build script. This is going to run this build. Okay, it is going to run everything in parallel so that our development is easier, so that everything refreshes automatically. Okay, so and again, remember this workspace flag. It is telling where this build command is located. In this case, run the build command from workspace mod.js/core. That's all it is doing. Okay, so build core, and let's also do the same thing for our test. So in order to run Cypress, before we did npm run test component UI Cypress open, but over here in the root package.json file, we'll do test npm run test colon core and npm run test component UI script from the mod.js/core workspace, and this is going to run the script from the core package.json test component UI. Okay, so let's remove that end comma there, and there are just so many things that we will be doing here. So even I'm getting lost. This is how big the code base is. But once we have everything set up, and once we really get familiar with this, it's going to be so much clearer. And that is also the reason why we have this big diagram. I've been intensely focusing on this diagram. I've been telling this to you all the time to look at the diagram so that we know what this structure is, so that we know how everything is set up. Okay, but for now, let's save that root package.json file, and then let's see if these three scripts are working. So in the mod.js in the root folder, from the monorepo, we will try to run npm run. Now, since we already have these scripts, let's run npm run build core and see if this build folder indeed contains something. Okay, so let's run npm run build core. It did give us an error, but let's see if this is still empty. It is building it, but there are all these tons of errors. So let's run the build. Instead of the build, let's run npm run test core. Okay, so this is going to open up our Cypress window, and nothing should change here. Everything should be working fine. In typography, we still have that there, and let's go to console to see if there's any errors. I do not want any errors. Sometimes when you do this Cypress, you'd have to click it twice sometimes. I don't know why it does that. And then yeah, no, everything, there's no any errors. It is still console logging this printing, which we do not want this in production. So let's go back to that. This folder is still empty. We'll figure that out later. This is a production build, so we really do not need to worry about it as much in this video, but we will definitely have to fix this as we go on. Okay, but I just want to make sure that we can start writing components and testing it over here. So let's go to this typography component, That's under SRC components. And in typography, these are all ESLint warning. If I just remove that ESLint warning is going to go away. Let's remove that too. That warning is going to go away too. And let's remove that console log too. That warning is going to go away too. Let's change this color to blue, and it should auto reload everything and change the color to blue, and that console log is also gone. So that's the typography component that we will keep working on, and there are tons of other components like I keep stating all the time. But you know what, let's do this here in SRC, in core SRC index TS. I forgot about this. Let's import and export this typography component from within index TS, because this build folder not having anything is bothering me. And I'm making video, speaking, watching my notes and everything at the same time, so my brain is really frozen right now. I cannot think of any I cannot think why that CJS and ESM is empty. But let's import the typography component, because this is the index.ts file for the core package. And what happened here? So index/components. So this is importing typography component. Here's the index file from components/typography.tsx, and all we'll do here is let's export this too, because we did not export it. Maybe that's why this build folder is empty. So let's export typography component. And so we have index.tsx, typography is exported, right? And we have index.ts. Let's look at Babel config. This should not cause any problem. Let's look at Babel ESM, same thing. CJS is set to CJS, ESM is set to, modules is set to false. And let's close that. I want to make sure, I really want this build folder to contain our production build before I wrap this video up. I'm sorry that this is happening. This happens all the time when you're writing something. It's just a part of our life, you know, and it's yeah, it can get really frustrating sometimes to just run into stupid things that we can't figure out all at once. But this is the part of our life. But let's try to see what's going on here. So we have SRC components, we have typography component. That looks good. Cypress is working. We have index.ts file that is importing the typography component, exporting it. That is good. And then in Babel config, I already looked at that. In Package.json, this is the core Package.json in build, because even when we are running the build core from the monorepo, it is still, this script is, as I said earlier, it's still going to look at this core build script. So here we said run everything in parallel, run what's build ESM, what's build CJS, what's build declaration. It is building declarations under types. It is building declaration, but for CJS and ESM, let's look at this two script, what's build ESM, Babel config-ESM, babel.config-esm.json. That should be working, because it would give us an error if that file did not exist. Let's run npm run build core from the monorepo, okay, and see what happens. Npm run build, it still gives us an error, which is okay, but this thing is still empty. So this is really bugging me here. I do not want to give up on you, so let me try to figure out, because if you are watching this video just to set this environment up, and if I don't do something in the build, it's not good. Eventually this works. I already have everything working. It's probably that we missed something somewhere in the middle. So let me review this. Let me see why this is happening. I'm sure there is just some minor things that needs to be changed, but let me try to figure that out, and I'll be back shortly. So I spent about 5 minutes there trying to figure out why this ESM and CJS folder is empty, when we should have a vanilla JavaScript typography component there. So let's come to this Babel config CJS. Again, I made a typo there, this plugin. It should have been plugins. Let's try to change that and see if it changes something. And for presets, that looks good. Same thing with the ESM Babel config for ESM. Let's do plugins, correct that spelling error, and let's try to run this and see what happens. npm run build core, and there it is. That was for CJS. It did build CJS, not ESM. But when we ran npm run build core under CJS, there is this index.js file. Okay, that is Babel is doing its thing of translating our source code into JavaScript. And for typography, we have typography component there. So that's what Babel translated our source code to, and same with typography.spec.js. We do not need this test file in the production build, but we will leave that for now. But the point here is the CJS folder is Babel is working with CJS, not with ESM. So let's see why this is happening, and I'll be back yet again. So in order to debug this, okay, I have not figured out what the problem is, but I wanted to get back into the video and come up with a few remedy here. So CJS is working okay. For ESM, it's still empty. So let's do one thing here. Let's open this core package.json file and switch the terminal here so that you are in the core directory. We will run a command here, and this is why we have all these scripts. This is where this script is really handy. Okay, so we have each individual script. We're running this npm run build core, right, from the root folder. But let's try to run the unwatched version of these scripts. Let's try to run this build ESM. So, well, not unwatched. Let's just try to run this watch build ESM, because right now the ESM folder is empty. Let's see what it does, and then we can figure out the problem, figure out what's going on. So npm run watch build ESM. Let's see what that does. There is an error. So let's read this error, because maybe that's why ESM. Let's run, before I even read that error, let's run the same thing for the CJS, because CJS does seem to be working fine. So npm run watch build CJS, see if it gives any error. It did not give any error. For when we ran npm run watch build CJS, did not give any error. So where is the problem? We have everything the same, right? There's no any difference. For watch build CJS, there's no error. Let's try to run, let me clear the screen, and then try to run watch build ESM. And now let's read the error here. So when I do npm run watch build ESM, it is looking at this script here. So Babel src build ESM, okay, under ESM folder, config file is that, and extensions is ts and tsx. Watch. Okay, so here's the error here. Babel preset env. The modules option must be one of the, the modules option must be one of false to indicate the module processing a specific module type common as AMD system as auto default, which will automatically select false if current processes known to support ES module syntax are common as otherwise. So the problem does seem to be in this ESM file. So let's look at it carefully here. Plugins. We need Babel plugins style components. For presets, we have Babel preset env. Modules, it's set to a false. It's a string. The module is set to a string here. In CJS, we have a string because we are specifying a string in modules. In ESM, we are setting it to false, but we are setting it to a string. This should not be a string. This should be a Boolean value that is false. Let's set that false, modules to false. And let's run this thing again. Let's run that ESM build. No error. Do we have something? Now we have it. That was the most minor. I spent about half an hour just trying to figure out what the problem was. That was just a typo. Okay, so that happens. It is, again, part of our life. But now under ESM, we have the typography component. Okay, this is the ESM version of it. And if you look at the CJS version, even the code is different. See, the CJS version and the ESM version of that the Babel translated our source code. You can see that there is a difference between ESM and CJS. So that is working. Okay, so now what we're going to do before I wrap this up, I've been saying that I want to wrap this up for an hour now. But before I wrap this up, let's one time finally make sure everything's working fine. Okay, so here's what we're going to do. Remove this NodeJs or Node modules folder. Let's remove that. And of course this tsconfig, I believe we had error before, but once you have Node modules folder in the root folder, this error is going to go away. If it does not, close VSCode and open it again, this tsconfig error will go away. Okay, let's remove this package.json file also. Let's remove this Node modules folder should not be here under core, because the core package does not have its own Node modules folder, because again we are using a monorepo architecture. This core package should inherit everything that it needs from the mod.js, from the root folder's Node modules folder. This Node modules folder had some cache. Okay, yeah, now we can get rid of this easily, but let's delete that for now. It is not containing anything. It is just containing some npm cache content. Let's remove this build folder too. Okay, and the VSCode stays. This is the settings. Do not delete that VSCode folder. It is the settings for VSCode in order to work with Prettier and Eslint. So now let's come to, now we have everything under the monorepo. Let's come to the root folder. The first thing we'll do is we will install everything we need in the root folder. These are all the dev dependencies. So run npm install. So that did take a little bit of time, but all the dev dependencies are installed, and you can see there is a Node modules folder in the root mod.js folder. There's also a package.json file. Let's close that, and let's open that package.json file because we'll need to look at the scripts here that we want to run. And let's also keep this packages folder and core folder open to see if there's any changes. Let's run npm run. Let's remove this script here. We really don't need that. Okay, I wanted to put that in earlier, but if we need it in the future, we are going to put it back in. But for now, let's just keep everything else super clean. Okay, so npm run. Let's try to build the core package first. So npm run build core, and remember to run this in a root folder because we are using a monorepo architecture. No errors. The build is done. Inside core, we see a build folder. Under that, we have CJS. We have the component, typography component. We also have ESM. We have the typography component, and in index.js, it is importing and exporting the component in ESM, and again in CJS too. it is importing and exporting that component. Okay, so the build, and for types, again, we will fix this. We do not want Cypress when we deploy this to npm to production. We do not want this folder here. That is just going to increase the package size. So, but we will take care of that later in the series. But for now, inside types, there is again src components. This should be a little different because we want this organized really well. Under types, there will be 4 other folders here for all our 4 packages, and inside each of those packages we'll have this src components, typography, and all that. Okay, but for now, let's also run this let's run Cypress to make sure that nothing there is no any problems. So npm run test core. Let's run that, open up Cypress here, and let's reopen that and go to component testing, go to Chrome, and here is the spec file. It is working. If there's any errors, there shouldn't be. So Cypress is it is working. So I think that should be it for this video. If you are following this series, there is so much things that we will be doing throughout this series. But if you are just here wanting to set the environment up, I hope you found this video useful, especially if you are just watching this just to set this environment up. I know there were some problems that we came into, but everything should be working fine. If it does not work in yours, can you let me down in the comments below if you face any problem, if you face any errors? Because I think I've been working on this for the past 1 year in setting everything up and finally getting something to something ready for production. So I'm sure that there isn't a problem in my code base, or by that I mean everything works as expected. But if it does not work in yours, feel free to let me know down in the comments below, and I will try my best to help you figure out what the problem is. Okay, so that was the first part of the part 3 of this series. I thought I would make a separate video for the rest of the things that we'll be doing in the series, but for those folks that are following this series too closely, I think you will need to watch the rest of the video in order to have this complete architecture like in this diagram. But up until now, if we're just wanting to set up a React, TypeScript, Webpack, Babel, Eslint, Prettier, this development environment, I hope you got what you wanted. And again, I hope everything is working fine for you up until this point. If you have any problem, let me know down in the comments below. I would love to hear the errors or the bugs you are facing and try my best in order to solve it. But for the rest of the video, here's what we're going to do. And I'm sorry that this video is already getting too long, but this is reality here. Okay, but let's try to set these 4 packages up, because what happened was, if we come to root package.json, we did configure Cypress for component testing, but I also wanted to do this Vitest for unit testing and integration testing. So we will use Vitest. So let's go ahead and you know what, let's set everything up in this video. I don't know how long this is going to be, but once we have everything up, at least for the component library, okay, let's forget about the documentation website for now, because this documentation website is going to be later in the series, all these Next.js apps. For now, we are in the beginning phase, so we will deal with the packages here. Okay, so for mod.js core, we have a typography component that is working in Cypress. Let's go ahead and set up this another package called mod.js icons too. So I wanted to set everything up, set all the environment up, so that when we actually start writing component code, when we start doing other things, we do not have to worry about setting up the environment again, and we also do not have to worry about if something is gonna fail in our development environment. Okay, so in order to begin this, let's again, if I'm repeating this, I'm sorry, but let's set these four things up with at least one function or one component or at least one file and one test file in each of these. Okay, so to get this going, let's come to mod.js root package.json file. And within this file, we will review everything again. mod.js monorepo, good. For workspace, this will, because we will have four packages, mod.js core, icons, helpers, and utils. So let's include all of those two packages core, this four of them here, mod.js icons, and also write utils, and also write helpers. So this will contain some of the helper functions. So put comma there, comma there, comma there. Let's not there. I'll remove that comma. And private is set to true, so we specify workspace. Those are the four packages. And later on, right in this workspace property here, we will also specify docs / mod.js core site or marketing site and all that. But for now, we're not in docs yet. Let's focus on the getting this component library environment set up. Okay, so that in scripts, so let's put in a few more scripts here. So we have the script and test for core. Let's do that for the other three packages also. Okay, and before we write this script, let's actually create these folders inside packages folder. So there is core, we will have icons folder. Okay, so let me close that, and inside packages we will have another folder called utils, and final folder called helpers. Okay, so come back to the diagram. We have these four folders, these four packages. These are the packages that will actually be deployed to npm. So under packages, core, helpers, icons, and utils. So under the core package and the icons, let me close that. The core package and the icons package is going to be similar. The difference is that the core package will contain the core components like button, all the HTML elements, or accordion, drawer, and all these components. mod.js icons will contain the SVG React component. Okay, so for mod.js icons also, we will be testing and building this with Cypress. So a lot of things for the core package and the icons package is going to be the same. So what I'm going to do is I'm going to, and same for the util. So this core package and icons package will be similar, and also the utils package will be similar in a sense that this core package, as you can see in the diagram here, if we come to mod.js core, this core package will contain the React component that we will build. We'll build button component, drop down, all these components, and over 100 other components. For the icons component also, these are all React components, right? For email icons, settings icon, these will all be React components. For helpers are just plain JavaScript functions, vanilla JavaScript functions. So helpers package will not be similar to all these three other packages, but the utils package will also be similar to mod.js icons. So in utils, we'll have theme provider, light theme, dark theme, and React components like higher order component with layout and use media query hook. So these core, icons, and utils package will be similar to core in a sense that we will build these three packages, core, icons, and utils, we will build and test with Cypress. Okay, so those are three packages. And for the helpers package, this is for plain JavaScript functions, and we will use Vitest and not Cypress. We will use Vitest to write and test some functions. And in this video, just like we did with the typography component, we're gonna have one component for each of the packages and see everything work, so that in the next video we can start directly into writing components and writing functions and making everything work. Okay, so what I'm going to do now is I'm going to, on my computer, I'm going to duplicate this core folder, and then I'm going to paste it over here, and this icons and utils will and we'll just modify a few things in this icons and utils package. Okay, so just to speed up things a little bit here, I made a copy of this core. I made 2 copies, core copy and core copy 2. So now let's just remove this empty icons folder. Let's also remove this empty utils folder. I had planned this. It's not this unorganized, but there's just so much things going on in this video. That's why I am almost everywhere. I seem to be everywhere out here, but let's rename this core copy to utils. Okay, so this will be the utils package. It already has all the things we need for Cypress and all the configurations for for Babel and everything else for utils. And let's do the same for, so this core copy 2, let's rename this to, what was that, icons. Okay, so now we have 4 packages: core, helpers, icons, and utils. So in each of these, okay, so the core is working fine in icons package. Let's start modifying this in tsconfig.json. Let's come from the start from the bottom here. In tsconfig.json, everything should be a-okay. I don't think we need any modification here. Okay, so that's tsconfig.json, looks good. Let's close that. In package.json, we will come to this in just a little bit. Let's open Cypress config. So for Cypress config also, everything looks good. Okay, and Babel ESM and CJS, we don't need to do anything there. In SRC folder, in icons, we will not have typography component. Instead, in components, we will have, let's create a new folder called, we will animated loading icon. This is just we will render a simple SVG icon here. So animated loading icon dot tsx. Okay, not dot tsx, that's a folder. Animated loading icon, and also let's make animated loading icon dot spec dot tsx, and again we will run this in Cypress. Okay, and of course the source file, that is animated loading icon dot tsx. Okay, so these are the 2 files. We'll be writing a animated loading icon component. This will just be a round thing that for loading purpose, whenever you click on a button, we can show this animated loading icon, but we'll write the code for it in just a bit. But first, let's set this up. And same in index.ts, we do not have typography under core. We have animated loading icon, so this is not going to do that. So actually, because we do not have a declared or defined here, let's actually write this simple animated loading component. So this animated loading component, we will, let's import React from React. That should not be that. Import React from React, and let's do const mod animated, and this is just a naming convention that I am using for my library. You can change it if you want. Animated loading icon is equals to, we will use styled components just like with typography component. Okay, look at the typography component, and then this is the same thing we are doing here with just minor differences from styled components. Okay, so we are declaring mod animated loading icon. We are using styled from styled components, and we, just like with typography, we used h1. In this case, we will use an SVG element. Okay, and we will provide a height. For now, let's hard code a value. So let's set that to maybe 2 rem, And let's also hard code this value. These values will not be hard coded later in the series, or when we start writing icons component. We will need to give the user as much ability to modify the styles or the behaviors. So we'll try to do that, but just for the setup purpose, again, this is again still part 3 of the video. So we are doing everything to set up here. Okay, so stroke will be let's specify a color for stroke. I will just specify green color. Okay, and let's declare that animated loading icon component, and we will just return this mod loading icon that renders an SVG element, and we will close that. Okay, and inside here is where we will write the actual loading icon. And before we do that, because we are using TypeScript and we want to make sure that TypeScript works in the icons package also, just like it worked in the core package, so let's define an interface here, just like we did with typography component. So I'm going to call it just simply icon props, and we will move this to a different file here soon in the upcoming videos, but for now we will specify a fill property, which I don't think we need to do because we are hard coding this value. Let's just to see that TypeScript is working, what we can do is this animated loading icon will actually have a stroke that the user can provide. So right now it's hard coded to where is it? It's hard coded to green, but when we run this in Cypress, we can provide our custom value also. So let's do that, and also to make sure that TypeScript is working. So I'm defining a TypeScript interface called icon props, and I'm specifying stroke. That's STROKE stroke, and I will provide this icon props here. And this should be animated loading icon. I'm making a lot of typo here because of my keyboard setup and where my mic is. I have to stretch in order to type it in. I'm trying to set this, have a nice setup for when I make videos, but I'm still not there yet, not quite there yet. But so let's export default this animated loading icon component. Okay, and over here, let's specify stroke, and we will dive deep into, I will explain all the TypeScript that we're writing, all the code, most of the code we're writing, but for now we're trying to set this environment up. It's been too long, so I really want to get this done as soon as possible. So let's, I'm not going to explain anything here quite yet. Everything we're doing, just copy and paste it just so that you have the environment set up. So stroke is from icon props, that's good. And over here, we will do not need to do anything. We will pass in props here, but for now leave it as is. Okay, and then we will here define a circle element, and inside the circle we will specify cx is equals to 25, cy is equals to also 25. Fill will be, and these are all SVG attributes. Okay, so if you go into MDN and look at all the attributes, you will SVG attributes, you'll find it there. But for now, let's just get this thing going here. Okay, so fill is transparent. Stroke will be the user supplied value of stroke that we defined up here, and also in this in as a parameter. Okay, so stroke will be stroke And let's also supply stroke width so that the stroke is actually visible. Stroke width is equals to, let's apply it to 3. And let's also define a radius for the circle. Radius, we can have it, let's say 15 for now, and there is stroke dash array. So this will be a really tedious number here. I'm just gonna copy and paste, but you'll have to type it in because I do not have the source on GitHub yet. So that's the number for the stroke dash array that will give us a nice animated loading icon. Not quite yet, because we will need to actually define the animation here. So there will be animate transform, and we'll specify attribute name is equals to transform, and type is equals to rotate. Repeat count is equals to indefinite, and then duration we will do 1 second. Values will be this value, and there is also another property called let's do that, and we can close that animate transform. So, and let's save that. You can see that Prettier is doing its magic of formatting everything for us there. So that's the animated loading icon. Copy this just so that, copy the code here just so that it works in your environment too. But we will explain how to create all of this in the later series, because it's not possible to write each of these values manually when developing it. There are other ways to do it, but we will come back to that later when we actually start developing icons component in the future videos. Okay, so let's save that, and in index.ts, now since we have animated loading icon, we can copy this animated loading icon, and that's under components, and inside animated loading icon, and inside animated loading icon there is this animated loading icon component, and we'll just export this animated loading icon. Okay, so we have that. Let's close that, and for spec we will come to this later, but for now let's verify that everything else is all good here. So under src we have that. We still have to work on this package.json, so I'm going to keep this open, and I'm also going to keep this spec file open. For Cypress, we don't need to change anything here. We will be doing maybe adding some custom commands, but we can do that later when we start building out the components. And let's delete this build folder from the icons package. So that's that, and then let's come to this package.json. Let's rename the package name to mod.js/icons. Version is still good, 1.0.0, and in everything else should be the same besides for the script. Exports is good. It will be not under core. This will actually be build/types. We will come back to this. This is mainly important for production. We're not there yet. We're not there in deployment today, but this types will be, let's set that to build types src index.d.ts for now, but this will really be under build/types /icons, but for now let's just leave it to that. And let's go ahead and write the scripts just like we did with core. We have what's build ESM. That script remains as is. CJS scripts also remain as is. TypeScript also remain as is, because we copied the core folder, or at least I did, and then I just renamed it to icons, right? Because core and icons are going to be the same. So that's that. On what's also going to be the same. And component UI, Cypress open, this is also going to be the same. Component also, headless also going to be the same. Everything else is going to be the same in the scripts. Okay, and for peer dependencies, we still need React DOM styled components. I think that should work. We will again come back to this as we go on with the series, but now let's try to run this just like we ran. You know what, before trying to run this, let's go to root folders, mod.js, package.json file, and just like we did with core, we'll need to do the same with the icons package also. So I'm going to copy that. The workspace property is already specified with icons, so that's good. And we'll just rename that icons to, or core to icons, and this will also be test icons. Okay, so I think let's try to run this, and don't forget to change the workspace to icons, because now we are running this script from the icons workspace or the icons package. Okay, so icons, and let's run npm run build and then see what we get. That is not that. We'll need to run npm run build. We're not running core, we're running icons, so npm run build icons, and there is an error here. Must not have multiple workspaces with the same name. This is saying that packages core, packages utils. Because I duplicated that folder, let's try to run, let's try to clear, because I duplicated that core folder, right? And then pasted it right over here and renamed it to icons. So that's why this is happening, probably because of a cache issue. So let's try to clear the cache. So npm cache clean, I believe this is the command to do that, npm cache clean -f. So it is doing it. So let me run that yet again. Doing it. Let's now run npm run build icons. It is still giving us that error. So I spent a few minutes there trying to figure out what is happening. It is still saying that must not have multiple workspaces with the same name, and clearly we do not have multiple workspaces with the same name. For example, in core package, if we go to package.json file of core package, the name is mod.js/core. Okay, and then in icons package.json file, we have mod.js/icons. So the package name is different, the workspace name is different, but over here in icons package, let's change that to icons. I don't think that's going to do anything. And just like with core 2, this types here, this is types will be under build, and types folder will have core. Just like that, we will also have icons folder. Okay, because we want to be consistent throughout the entire project. So in icons, let's search, is there any word called core? No. In core, there is already 3 of them. There shouldn't be any icons here. We never changed anything on the core package since we started working on the icons. So let's change this to here, and let's run the build again, and this is still giving us that error saying must not have multiple workspaces with the same name. Package mod.js core has conflicts in the following paths: workloads, projects, mod.js packages core, mod.js packages utils. I'm sure it's because you might not face this in Windows, but in Mac, I've been having a lot of this problem about npm caching things automatically. So I think it's a cache issue because we copied that. Let's just copy and paste that and see what ChatGPT tells us. It is not defined in multiple paths. Okay, so check package.json, we did that, right? Workspace configuration, ensure that each workspace like mod.js core is defined only once in your project package.json file. If you have multiple entries with conflicting paths, remove or correct them. You know what? I just remembered something as soon as I read things about workspace. Things are everywhere here, but to get Prettier working, so as I remember this, let me tell you this here. I will probably add a caption saying what needs to be done, but with Prettier to work, you'll also need to go to settings. Okay, this is something that says I remembered. You'll need to go to settings in VS Code. If Prettier is still not working for you up until this point, go to the settings in VS Code and go to make sure that if you are in Mac, it's different, but in Windows you might see different things here a little bit. But in user, make sure that for formatting, make sure that format on save is checked, and also make sure that the entire file is getting formatted. Okay, this is really needed for Prettier. If you don't check on this, on format on save, then Prettier is not going to auto format it. Okay, so make sure you do this. I forgot to mention this about Prettier earlier when we did the Prettier and Eslint, but this must be absolutely done. Under user formatting, it's checked to format on save. If this does not work, try setting it up in the workspace too, because we are using VS Code workspace. In my case, I did not have to click on this format on save. It depends on how your operating system, your main operating system account, how it is configured, but in my case, I did not have to do that in workspace. I did not also have to do that, I believe, in this mod.js folder also. I did not have to check that on. Prettier is still working fine, but I did have to do this under user text editor formatting. Check that format on save. Okay, so that was for Prettier. Again, I will put a timestamp. So I recommend, this video is getting super long, so I recommend that you watch the timestamp so that you can jump to whatever section you want to watch or you are facing problem with. Well, let's get back to this little problem here that we are having. I don't know, sometimes magic happens, and if I run this again, sometimes it works, but it did not. Cool. So you know what happened? This took a lot of time for me to figure out, but the reason that this script is not working, or it is giving us this error, is of course because I made 2 copies of this, of the core package. I don't know if you did the same, but I did, and I got stuck. So I made 2 copy of, one is for core. I made copy of that core package. I renamed it to Utils. And I also made 2nd copy and then renamed it to Utils. And now I'm trying to run npm run build icons from the root folder. And of course, this is going to see 2 mod.js core with the same name, because we have not come to this utils package. We're working on the icons package, and utils package package.json file is still core. So let's change that to icons, and we don't even need to deal with that for now. But we'll deal with that later, all these other in types and everything. But now let's run it and see what happens. Let's run that. Now let's run build icons. It should work. It did not. So let's change some of these too. This is not icons. Oh my god, this is, I want to really get this completed in this video, and I want to get this today too. So that should have been utils and not icons. But now let's run it again. Okay, and this makes it that the package name for each of the workspace is the name of the package and not the same name. So now let's run it and see what we get. There you go, finally. Let's close that. So it is building it in icons package. That's what we are working on the build. Just like with core build, we have CJS. Inside that, we have components. We have animated loading component. That's a spec file is currently empty. But with the actual animated loading icon, we have the code there. So that's good. Okay, and for ESM2, let's make sure we have the component there. Types, let's make sure we have this there. And yeah, I think I said this would earlier. I think I said there would be 4 packages, but there wouldn't, because these packages, these types is only for the icons package. Okay, I made an error there earlier, but let's close that build. We have the build. Let's run Cypress now to see if that animated loading icon component is working. And in order to do that, we will need to run the spec file for Cypress. So let's write a quick, not really a test, but let's try to render this animated loading icon component. So this will, here what we'll do is we'll just import React from React, and we will do, let me just copy and paste from the core component, typography component, and then because this is going to be the same, just the component is going to be a different component. So let's copy and paste that. Instead of typography, let's import animated loading icon from animated loading icon, and then let's paste that there. And there shouldn't be a closing tag. I think this is a self-closing tag. So, and let's also rename this to animated loading icon and render animated loading icon. Okay, so now let's run, because we already have a test script for, let me close this. That's why I said the code base is already, it is getting quite long. That's why we followed monorepo architecture. You'll see in the end everything will be so nice and so consistent once you're used to it. But even for the new person looking at the code base, I think they will have a much better understanding. But let's run this now. Let's run animated loading icon. Yeah, and there are some stroke props, but let's see what happens. So for the icons package.json, we already have build, and we already have the build script, and we also have the Cypress open script, so that's good. So in the root mod.js package.json file, what we'll do is we already did that for build icons. We ran that, everything is built for the icons. And for the test, so let's run this. npm run test :icons. Okay, so let's click on component testing, everything, because I copied it from the core. Every Cypress is already set up. It should find that animated loading icon component, the spec. Let's click on that, and you can see that there is a loading icon which is not working properly here. So let's figure out what's going on here. So the stroke is applied, color is green. Stroke, we cannot supply stroke here, because can we? Let's try to do a stroke here and supply a red value for the stroke, so that we have red stroke. That is working, but there is some missing things there. Let's do, I'm not sure if it's just a spacing issue, but let's just add a normal div there for now, and provide some style, inline style, just to check if it is working. We'll add margin of let's say 32 pixels, and see what's going on here. Let's put that component inside the div so that the margin is applied. Let's save that. Let's come back, not there. Let's get away ChatGPT. The margin is applied. This icon should work correctly, but again, this is not the complete component. Again, the test is also not complete, and this is not the complete component. And we're at least seeing at least the icon is is circling and there is an icon, but we will fix this when we actually finish this component, because this is not the final product. Okay, this is not the final component. There are still things we need to do. So for now, let's leave it to that. We know that TypeScript is working, all the configuration, Eslint. If I save that, Prettier is working. If I use any unused variables, so let's say use effect, it is working. Eslint is giving us that warning. So in this setup for the icons is also complete, and don't worry about this animated loading icon not being rendered nicely here. The purpose of this part of the video is to set everything up. Okay, so let's get this off from here, and then we will do the same thing for the utils component also. This is going to be super simple here. We already did mod.js utils. Everything else should be the same. Just make sure that, because I copied this from core, I do not want any word called core in there. Okay, so that looks good. Let's close that. And for utils also, let's delete this build, because this build actually contains a typography component because I copied it, but utils will not have any typography component. Okay, so for utils, and everything should be just fine for this utils package. Here we'll be writing some utility functions like theme and all that, but I'm not sure if I want to get into that right in this video. But if you just write this some component here, maybe in utils, and because this is just a copy of core, right? Because the package core is working, the utils will also work, but we will come back to this later when we're actually writing React components or the utility components that the core package and every other package will use. So I think I'm going to leave this utils package as is for now, because just like the core and icons package, I know this is going to work. We tested it twice with the core and icons, it works. So that's all for the Cypress setup mainly, so that we can start developing core icons and utils. Let's do this helpers, okay? Because we have another package called helpers. This package is going to be different according to my structure, my use case. Yours might be different, but for now, just follow along, and then you can always change things in the future once you understand everything that's going on. Okay, so inside helpers, what we will do is create a new folder called src, and this Babel config, this Babel, CJS and ESM is going to be the same. So src, let's create a new file called babel.config-cjs.json. Let's create another file for the ESM. So Babel config esm.json, and let's copy the things from the core package, because this is going to be almost identical but not completely the same. Let's copy the CJS first. So Babel CJS this is in helper package. So let's paste that there. In CJS, because the helpers package is not going to be React components, these are only going to be plain JavaScript functions, so we do not need styled components. And for presets, we will need preset env, we will need preset TypeScript. We will not be using React in these helper components. These helper components will, again, going back to the structure, if you look at this, or the diagram, this helper package will contain format phone number, format email. These are the helper functions that this format phone number will be used by the phone field over here, somewhere here. This format email function will be used by this email component here. Okay, so come back to this Babel CJS config, and over here we will because this is mainly for unit testing with Vitest, and we'll probably also do integration test, but let's specify a ignore property there, and specify everything that it needs to ignore. So Babel should ignore all the test files. Okay, and we will make this change in the core and the components that use Cypress too, because we will need to make sure that everything's optimized for production. But for development, let's tell Babel to ignore all the .ts files, okay? And let's do the same thing with ESM as well. And the JavaScript functions we will be writing, that's why there is a TS file. You might be wondering, well, why not JS here? Because you just said that all these functions that we'll be writing are plain JavaScript functions. Yeah, they are plain JavaScript functions, but we will write it in TypeScript, okay? And Babel will compile that TypeScript and then convert it to plain JavaScript, okay? The only thing that I meant when I said that this will be plain JavaScript is that none of these functions, it's not a React component. These are just normal functions, okay? So that's what I meant by that. So that's why there's a .ts. Let's do the same thing with the ESM version of the library. And over here we have presets. Make sure you spell that correctly. Preset env modules is modules. We'll set this to false. Remember what happened before when we had a string there instead of a boolean. So modules is set to false. Make sure that it's not a string, it's a boolean. And Babel preset TypeScript, and ignore again .ts files, okay? So that's for Babel. Let's get rid of some of these here. We are mainly focused on the helpers package. So we have Babel, and also this helper package, we will specify this as a node project. So let's cd into, yeah, right over here, let's cd into packages, helpers, and let's do npm init. Let's keep pressing enter, and this will give us a package.json file in helpers, src package.json. Let's rename this to @modjs/helpers. Okay, this will still be under modjs scoped package. So modjs helpers description, let's leave that as is. Just like with the other three packages, we're going to have to specify, let's remove that first main property, main property, and we're going to have to specify the path to the index.js file. So build CJS index.js, ESM index.js, types index.d.ts. And let's actually copy and let's pull it out from package.json. There are a few things we can copy here. Let's copy this exports field and paste it for the helpers. So exports, this, I explained this in greater detail earlier. I'm not going to do this again, but put that exports field, exports property there. Also set private to false, because that should be a boolean value. So private to false, because helpers package will be deployed to npm. We also need another property called files. So these are and we'll specify build. This build is the actual folder that will be deployed to npm, okay? And we have also the side effects property. We will set that to false. And exports field is good. Let's come to the script section here. And this will just be like a core scripts. So let's copy those scripts and let's paste it over there. Okay, so the build is good. What's build ESM? Everything should be the same here. And tsconfig, that's good. On what's also good. That declarations is good. This is where it is different. So test component UI. So instead, because these are the helper functions that we'll be writing test to, so I will rename this to test unit UI. And you will see Vitest also has a nice UI that's easier while in development. Vitest dash dash UI. Okay, and same thing for the headless. We'll just do, it might be better to call this not headless but something else, but we understand it, it's not running in the browser. Okay, that's all it means. npm unit headless, and this will be Vitest run dash dash coverage. Okay, and this is going to, this coverage flag is going to give us a test coverage of the functions we write, and you'll see this in a little bit in this video. Vitest automatically gives a test coverage, Cypress does not, because if you look at the package.json file of the core package, this is using Cypress, right? This is, we do not have any coverage flag anywhere in Cypress, because for Cypress we would have to set the coverage manually, but for Vitest we can, Vitest directly gives us the code coverage. Okay, and same thing with the linting formatting, we want everything as is. Build also, that's as is, and pre-publish script. So that's package.json for you. So let's close that, and then the last thing we will do here for the setting up with this helpers is we also need a tsconfig, because this, all these functions that we write will be written in TypeScript. Okay, so tsconfig.json, and this is also just like with core package tsconfig, it is going to extend it from the base tsconfig that you see down here in the main mod.js root folder. Okay, but once you get used to this folder structure, it's, everything is going to be so clear. Like, I do not get stuck in trying to find out where my files are. I know it so well. I know where what file is located. I know that, but for you, because you are just watching this, it might be a little hard, but I'm sure it's not that complicated. But as you just work around this a little bit, it's a really nice folder structure. It's a really nice monorepo we have. Okay, so let's copy and paste that tsconfig there, and there will be some changes that we'll make here. So it is extending from base tsconfig, because this base tsconfig has all the TypeScript definitions that is used across the monorepo. Okay, so let's close that. For compiler options, we can set it to ESNext. Outer is set to build types. Target set to ESNext. We do not need leave here. Okay, let's get rid of that. And we also don't need Cypress here, because we are not using Cypress in helpers package. These are using Vitest to run unit test. So that's should be it for the tsconfig for the helpers package. And I want to make sure that in package.json, so let's do this nicely and neatly. This core should not be there, so instead what we'll do here is build /types /index.d.ts. that's where the TypeScript types are located for this. Okay, let me check, because I copied from core, I do not have any word there. Okay, so that's the package.json. Before we do any production, we're going to have a final look in each of the environment before we actually run the production build. But for now, I think this is still looking good. Okay, it's not that bad. So for helpers, let's come to this src folder. So inside this src folder, I will create a new folder called functions, and you can name this whatever you want, but I'm just calling it functions. And I'm going to create another folder here, just like with the core. We want to the unit test and the component test to be the test code or the spec to be right beside the source code, so that it's easier to find. But for end-to-end test, that's we're not going to have it right beside the source file. And also for the integration test, the source code are probably not going to be right beside, or the test files are not going to be right beside the source files. Okay, so for functions, create a new folder called isEmpty folder, and this is the folder name. Okay, isEmpty. It's not an empty folder. This is just a very simple function we'll write just to make sure that Vitest is working. Okay, and the TypeScript and everything else is working. So it's a TypeScript file. It's not a TSX file. TSX is TypeScript with React JSX. .ts file is only TypeScript file. So this isEmpty.ts will eventually be compiled to isEmpty.js in the build when we're on the build. Okay, just like with the core typography in the build, we have typography.js, but this is we wrote typography.tsx. Babel compiled, translated it to typography.js. Okay. So let's write this very simple isEmpty function. There's nothing much going on here. So const isEmpty is equals to, I'm going to take a value from the user, and I will explain this to you once we are writing components, building components. But for now, just copy the code and then see if the entire environment is set up, okay, because this is the goal for this video. So if the value, we are trying to trim the value, we are trying to take the value from the user. This isEmpty will probably be used by probably name field or even email field. If the email is empty, it's an error, so that's what we are trying to do. So isEmpty takes a value that is a string and it returns a boolean, okay? So that's all this TypeScript is doing. Declaring a isEmpty function, taking a value as a parameter from the user. That value must be a string, and the function will return a boolean value, either true or false. Okay, so this is what the function will return, and the way we check what the function returns is if value.trim, we are removing the leading and trailing white space with the trim function. This is a built-in JavaScript function. If value.trim is empty string, then what are we going to do? We'll just return true. It is empty. If not, what we'll do? We will return false if the value is not empty, and then we will do export default is empty. Okay, so that's the very simple empty function, isEmpty function there. Let's write a test for this and then see if Vitest is working. So isEmpty dot, and I'm not going to call it a spec this time. I'm going to call it a test. It's spec and test, they almost mean the same thing with really minor differences, but people use that term interchangeably. Okay, so let's write this test here, and I said that we will be following test-driven development, but since we already have the source code, but again, just for the development environment setup, and this is what we're going to do. We just want to make sure that Vitest works. Describe it and expect from, not from Mocha, okay, it should be from Vitest. And you see that the Eslint is already working. We did not have to. This is the beauty of using monorepo. Okay, we configure Eslint, Prettier, everything out in the root folder, in mod.js folder, and every single packages inside it is going to inherit it. Okay, we did not set up Eslint or TypeScript or anything in the help us package. Okay, we did it once in mod.js root in the monorepo. That's the beauty of using monorepo. I find it super helpful, and I think a lot of companies are transitioning to using monorepo too, and I believe they always have used the monorepo architecture. So but let's write this describe block here, and I will just write the name of the function is empty, and let's write a one test case. It should return true for empty function, should return true for string with only white spaces. Okay, and then const result or res is equals to isEmpty. We're calling that function, and then we are passing in that empty string, and then once we pass that in, we expect the result dot to be, we expect it to be true, isn't it? Because that's what our function is doing. If the value is an empty string, or even if there is a white space using this trim, we are putting a white space. We want to make sure that the trim function works, but we are not checking for trim function, whether trim function works or not. we're not checking for trim function, because this is not a pure isEmpty function is not a pure function, because it has dependency, and that dependency is a trim function from JavaScript. But when it comes to testing, so that's why I made that I will make a separate video about testing, everything you need to know about testing, test doubles. And there is mock, unit test, integration test, end-to-end test. There is also component test when it comes to front-end development. There are test doubles like mock, stub, fake, dummy. So I'm going to make a separate video about that, so that you have in-depth knowledge about testing, about what needs to be tested. But in case of this isEmpty function, this is an impure function, meaning that it has dependency, it has side effects, because we are calling this trim function that is built into JavaScript. But our goal here is to test this isEmpty function and not the trim function, because we assume that the trim function that is provided by JavaScript, it's built in, we assume that it has already been thoroughly tested, and the trim function works. There's no reason to test this trim function. Okay, but I will make a separate video about testing and test doubles in a separate video. But for now, let's get back to this here. So the user is providing an empty string. It does have white space, but again, we are using that trim function to return true if there is a white space and no any other content. Let's also write now the test, just one more, to return false for string with not only white space, for non-empty string. So non-empty string. Okay, so return false for string, false for that's what I meant. So return false for non-empty string, and we will provide a non-empty string. I'm just going to write my name here, Prashant Puraseni, that's my name, is empty. So this should not be empty, the result should be false. Okay, because the isEmpty function is not empty, so we're returning false. Here isEmpty function is empty, so we're returning true. So that is the case for this is test case, 2 test cases, and the entire test suite only contains 2 test cases for the isEmpty function. Okay, so now let's try to run this. I think we have almost everything set up in order to run this. But you know what? No, not yet, because we will run this not from helpers. Okay, we are using a monorepo architecture. We'll go back to the monorepo, to the root folder, to mod.js. Let me get rid of that one terminal there. So in root package.json, we will, let's clean this up a little bit. So this build icons, I want to have it all the build scripts in close together with each other. And also for you know what, we never did that for utils, so let's do that for utils also while we are here. Okay, and let's do that for, let's do the build for helpers also. Okay, that we are currently working on. So npm run build, this will be, the workspace will be mod.js/helpers, and in utils the workspace will be mod.js/utils. Okay, so core icons, utils, helpers, core icons. So let's also do the test for the 2 other packages. So core icons, utils will still be utils. So utils will still run that Cypress. Okay, Cypress component testing, and the helpers will run npm run test component UI. This will run from the helpers. Okay, let's not forget comma there, not at the end. So we have 4 builds for the 4 packages. We have 4 tests for the helpers package, and now let's make sure that the helpers package.json actually contains this test component UI script. I think it does. Test, it's not test component UI, of course, because this is unit test. So we'll do for helpers test unit UI. Okay, and for build, I think it should be the same, right? Yeah, but for testing, test unit UI, because we are unit testing that isEmpty function, that simple isEmpty function. and helpers test unit UI mod.js /helpers core icons utils helpers core icons utils helpers. Make sure that is correct there. So now let's come to root folder and let's try to run this script here. So first thing we will do is run this run the build on the helpers package. So we'll do npm run build helpers. Okay, and that is going to run. Make sure you do it on the, it doesn't matter even if you want to go cd into the helpers function and then run the build, but you'll see this later how easy it is when you have a monorepo and you can run every single commands through the root folder. Okay, and this is going to be especially important when we get into the documentation side. We can manage every single thing from the root folder. Okay, from one terminal we can manage everything else. Okay, so I'll manage the dependencies, run the scripts, everything. So let's run that. Npm run build helpers. There is error, it looks like, but we have build, and inside build CJS and ESM we do not have anything there, so it looks like we faced the same problem as before. So let's figure out what's going on here. So what is the error? The error is saying that cannot find module Babel config-esm.json. So do we not have it here? Of course we do not have it here. Or didn't we do that for utils? I think we did that, but let's see. In helpers it is saying that it cannot find it because this should not be under src. It's not finding this Babel config because the Babel config is under src under the source. This should be outside in the root helpers folder. Okay, same with the ESM, it should be in the root helpers folder, just like with our core package and every other package. We want to be consistent as to how we are configuring our environment. Okay, so now the Babel config CJS and ESM is in the helpers root. So now let's run npm run build helpers and see if this ESM and CJS are filled, and they are. In under ESM, under build, under ESM for the helpers, we have isEmpty function. This is, we wrote this in a file ending in .ts. In source isEmpty.ts. In build we have Babel doing the job, transpiling that TypeScript code into JavaScript with a file ending in .js. We don't have any of the TypeScript here, even though we used TypeScript in order to specify the types. Okay, so I think that's a clear visibility into the difference between JavaScript and TypeScript that I tried to explain in the beginning of the video. But yeah, that's the isEmpty function, and it's good that we do not, like in core package, we have, when we are running the build, it also has this spec file which we will get rid of as we go on. But for now, the helpers package, it is looking good. We do not have that test file out in production, okay, because we really don't need that. So that's that. So now the build is done. Let's run the test and see if that test actually passes. Okay, so npm run test helpers. So you see, as soon as I ran that, this is a Vitest UI. For pass, we do not have. For test, we only wrote 2 tests. But what it is doing is Vitest is also running the test that is in build type isEmpty.test.js, which should not do. We should only have 2 test cases. So for this src functions isEmpty function, all tests passed in the file should return false for non-empty string. Let's check to make sure that these tests are actually running well here. So if we go to isEmpty the test file, so in over here this is empty. Let's type in my name there. I'll just type in Prashant, and so right now this is not empty. This should return false, right? So let's save this, and then Vitest gives us any error, and it is already giving us any error. And if you can see that one test fell, the other test is passing, because this should return true and not false. Okay, or this should no, this should return false, but then since we are checking for white space, we'll just do that, and maybe check for trim also, put extra white space there. So that's the Vitest setup. Let's quickly fix this also. This build types is empty.test.js. I don't know why Vitest is looking for this, but this has to do with let me try to think here. It is doing that because we do not have a config for the Vitest. So let's write a configuration for Vitest also and see if that helps. And of course it will, because we do not really need a config file to run Vitest. It's just that config file lets us add extra functionalities or whatever we want to modify. Right now it is looking at all the test files ending in .test.js, because that's let me see here, I got distracted. Test unit, but no, let's go ahead and do this, okay, because that we should only have 2 test cases. Right now Vitest is looking for this build folder also, and inside ESM we do not have the test file, but inside types we have this test files. So that's why Vitest is looking for this test file and running the test, running duplicated test, which we do not want. So we want to get rid of this. We want Vitest not to see this build folder. We want Vitest only to see this our source folder, this src folder, okay. So let's create that vitest.config.js in the root of the helpers package, okay. Make sure you do that in the root of the helpers package. Over here we will do import define config, and it is not this is from vitest/config, and we will just export default this define config, and then we will add some more properties here, okay. We'll say test, and we'll set the globals to true. We will also need the code coverage. I forgot about that because this did not give us any code coverage here. It will give us a nice code coverage in the terminal here. So, and Vitest automatically does that. We do not have to configure anything for that instead of besides this coverage object here. And we will just say include src / include every single thing that's in the src folder. Okay, so let's check for the code coverage first, and then we will fix that other thing there. So it is still looking at the build, right? Not just all the test pass, not just the src folder. It is also looking at the build, but it will also give us a test coverage. And in order to get the test coverage, here's what we need to do. We need to run this headlessly, okay. So in the root package.json file, helpers unit UI. Okay, so we do not have the script, main script here out in the root yet, but we can cd into packages/helpers. And then we will run npm run test unit headless, and then see if it gives us the code coverage. And it did. We have 2 test files, we have 2 test files, we have 4 tests. That's not true. We only have 1 test file and 2 tests. It is saying 4, as again it is because it is looking at the this build folder also. But you can see that we have all files. That's isempty.ts. That's our source file. We have 100% code coverage, okay. So for that's what you see, this 100 here, percentage of functions, percentage of lines covered, okay, percentage of statements covered, uncovered lines. If there was any lines we did not cover, then there would be some number here. But we have a very strong test for the isEmpty function, so that's why you see the code coverage here. Okay, so that's for the Vitest code coverage. For this Vitest, looking at that disconnected because the test is not being run. Let's cd back 2 folders back, and then let's do npm run test unit UI. What happened here? Test not unit UI. That should be from the root folder test slash or colon help is. Okay, you can clearly tell that I'm getting too tired here. This is a simple fix. We do not have this problem of test looking at the build folder when we are doing Cypress, so we will eventually fix this. Okay, this does needs to be fixed because when we are running the test in production, that is going to running this unnecessary test is going to cost us money, because in production when we run GitHub or deploy this to GitHub and run all the tests, there are going to be cost involved if we are not careful. So we'll try to minimize that as much as possible, and we'll also try to do every single thing for free instead of paying for anything. But again, we also do not want just unnecessary duplicate test trying to slow things down here, okay, when we do that. But I think that will be a fix for when we as we go on, as we start writing these helper functions and test each of the functions. I think we can fix that at that time. So let's close some of this. Before now, I really want to wrap up. I think I'm losing a lot of energy here, and I have been on the computer for about 8 hours now, and I've been I get up at almost 4 or 5 a.m. every single day. So, and I still have a half day that I need to cover. It's already 3 o'clock here in Minnesota. That's where I'm best. But yeah, I have but we will come back to this. But this is all the environment set up, and of course, as we go on, we will keep making changes. But for now, I think everything looks really beautiful. I really like how things look. We do not have even a single error anywhere in the code, which is really good. Okay, but as we now, we can actually start writing each of the packages out, start building components. And for there's this package.json in the root is going to be used. There will be a lot of scripts here, a lot of other things we'll include here, but we can do that as we go on. But for the purpose of this video was to set up an environment, set this architecture up. This is what I keep coming back to. And as of now, there aren't things that needs to be changed in this diagram here, but soon I think there will need to be things that will need to be changed. But yeah, I think that should be it for this video. In the next video, I think I will make a video about again explaining all about test doubles, all kinds of test integration component, mainly unit tests, component tests, integration tests, and end-to-end tests. Those are the 4 tests that we'll be focusing on throughout this series. There are tons of other tests that might not be needed in this series, but if we come across anything like that, we'll definitely discuss. But the next video will probably be about test and test doubles. I want to really explain that very, very nicely. I don't think anybody in YouTube has ever done that. Let me know if you find a good videos about, because I actually want to learn too. I know about testing, test doubles and all that, but I have searched on YouTube. There are some Google links that I found that were really helpful, but no person, I have not seen anybody explain the concepts of testing. All they do is explain about unit tests, and that's all they do. And unit tests are the most easiest to write. You saw how easy it was to write that isEmpty function. There is nothing much going on in unit tests. But when it comes to a lot of people, when they talk about unit test, then all they are doing is basically testing whether that isEmpty function works or not. And how simple is this isEmpty function? There is nothing well, this is a unit test. We are testing a piece of code, right? But there is just so much to unit test than this. And I think the topic about test doubles, I think you'll find that really helpful, because there's a lot of misconception out even in the industry, even for a enterprise developer. All they do, it can be confusing, because there is one umbrella term called mock that is basically ruining every single concept behind unit test. Whenever you talk about tests, then people want to mock something, and I ask people, well, what do you mean by mock something? Well, mock is, like, what do you mean by mock something? But when you're writing the test, that's not a mock. That's completely something else. Okay, and we will get into that deeper, and throughout the series as we write tests, we will talk about that a lot. But the next video will be about test and test doubles. So that should be it for this video. Let me clean things up a little bit here, so that the next time we come, this is exactly how I'm gonna start. Let me also clear this terminal. So in the next video, we will probably start from this, or we will start talking about test and then start from here. I hope you found this video useful. Would you mind hitting that subscribe button for me? So if you want to see more contents like this is my front-end development series. I also want to do a complete cloud series, especially with AWS, and I also want to do a complete backend development series, or API, that I actually had done the main stack API, I would say, MongoDB Express and Node API that I created. I think it's been almost 2 years. It took us 12 hours to complete that entire project. I have a nice demo of that API too, so if you want, you can go into my channel in the playlist and look for, I think it's titled under Learn Modern Stack in 12 Hours. I have a nice demo, and we built a robust API, but over there I had not done any testing. But I think we will use that API sometime soon in the future in my next series or next projects. So yeah, that's it. I will see you in the next one. See ya!